and the concept of the Rulliad ultimately leads to a deep unification between them. For what we now imagine is that the physical universe as we perceive it is just the result of the particular kind of sampling of the Rulliad made by us as certain kinds of observers. And the point is that we as observers can make other kinds of samplings, leading to what we can describe as abstract universes. And one particularly prominent example of this is mathematics, or rather meta-mathematics. Imagine starting from all possible axioms for mathematics, then constructing the network of all possible theorems that can be derived from them. We can consider this as forming a kind of meta-mathematical universe. And the particular mathematics that some mathematician might study, we can think of as the result of a mathematical observer observing that meta-mathematical universe. There are both close analogies and differences between this and the experience of a physical observer in the physical universe. Both ultimately correspond to samplings of the Rulliad, but somewhat different ones. In our physics project, we imagine that physical space and everything in it is ultimately made up of discrete elements that we identify as atoms of space. But in the Rulliad in general, we can think of everything being made up of pure atoms of existence that we call eames. In the particular case of physics, we interpret these eames as atoms of space, but in metamathematics, we can think of eames as corresponding to kind of sub-axiomatic elements of symbolic structures from which things like axioms or theorems can be constructed. A central feature of our interaction with the Rulliad for physics is that observers like us don't track the detailed behavior of all the various atoms of space. Instead, we equivalence things to the point where we can get descriptions that are reduced enough to fit in our minds. And something similar is going on in mathematics. We don't track all the individual sub-axiomatic eames, or usually in practice even the details of fully formalized axioms and theorems. Instead, mathematics typically operates at a much higher and more human level, dealing not with questions like how real numbers can be built from eames or even axioms, but rather with what can be deduced about the properties of mathematical objects like real numbers. In a physics analogy to the behavior of a gas, typical human mathematics operates not at the molecular level of individual eames or even axioms, but rather at the fluid dynamics level of human accessible mathematical concepts. In effect, therefore, a mathematician is operating as an observer who equivalences many detailed configurations, ultimately of eames, in order to form higher level mathematical constructs suitable for our computationally bounded minds. And while at the outset one might have imagined that anything in the Rulliad could serve as a possible mathematics, the point is that observers like us can only sample the Rulliad in particular ways, leading to only particular possible forms for human accessible mathematics. It's a very similar story to the one we've encountered many times in thinking about physics. In studying gases, for example, we could imagine all sorts of theories based on tracking detailed molecular motions. But for observers like us, with our computational boundedness, we inevitably end up with things like the second law of thermodynamics and the laws of fluid mechanics. And in mathematics, the main thing we end up with is higher level mathematics, mathematics that we can do directly in terms of typical textbook concepts, rather than constantly having to drill down to the level of axioms or eames. In physics, we're usually particularly concerned with issues like predicting how things will evolve through time. In mathematics, it's more about accumulating what can be considered true. And indeed, we can think of an idealized mathematician as going through the Rulliad and collecting in their minds a kind of bag of theorems or axioms that they consider to be true. And given such a collection, they can essentially follow the entailment paths defined by computations of the Rulliad to find more theorems to add to their bag. And yes, if they put a false theorem, then because a false premise in the standard setup of logic implies everything, they'll end up with an infinite explosion of theorems that won't fit in a finite mind. So in observing the physical universe, we talk about our different possible senses like vision, hearing, and so on, or different kinds of measuring devices. In observing the metamathematical universe, the analogy is basically different possible kinds of theories or abstractions, say algebraic versus geometrical versus topological versus categorical, and so on, with new approaches being like new kinds of measuring devices. Particularly when you think in terms of the Rulliad, we can expect a certain kind of ultimate unity in the mathematical universe, but different theories and different abstractions will pick up different aspects of it, just as vision and hearing pick up different aspects of the physical universe. But in a sense, observer theory gives us a global way to talk about this and to characterize what kinds of observations observers like us can make, whether of the physical universe or the metamathematical one. In physics, we've seen then that in our physics project, how this allows us to find general laws that describe our perception of the physical world and that turn out to reproduce the core known laws of physics. In mathematics, we're not as familiar with the concept of general laws, though the very fact that higher level mathematics is possible is presumably in essence such a law, and perhaps the kinds of regularities seen in areas like category theory or others as the inevitable dualities we expect to be able to identify between different fields of mathematics. All these laws ultimately rely on the structure of the Rulliad, but the crucial point is that they're not talking about the raw Rulliad. Instead, they're talking about just certain samplings of the Rulliad that can be done by observers like us and that lead to certain kinds of internal impressions in terms of which these laws can be stated. Mathematics represents a certain kind of abstract setup that's been studied in a particularly detailed way over the centuries, but it's not the only kind of abstract setup we can imagine. And indeed, there's even a much more familiar one, the use of concepts and words in human thinking and language. We might imagine that at some time in the distant past, our forebears could signify, say, rocks only by pointing at individual ones. But then there emerged the general notion of rock captured by a word for rock. And once again, this is a story of observers and equivalences. When we look at a rock, it presumably produces all sorts of detailed patterns of neuron firings in our brains, different for each particular rock. But somehow, presumably essentially through evolution to an attractor in the neural net in our brains, we equivalence all these patterns to extract our inner impression of the concept of a rock. In the typical tradition of quantitative science, we tend to be interested in doing measurements that lead to things like numerical results. But in representing the world using language, we tend to be interested instead in creating symbolic structures that involve collections of discrete words embedded in a grammatical framework. Such linguistic descriptions don't capture every detail. In a typical observer kind of way, they broadly equivalence many things, and in a sense reduce the complexity of the world to a description in terms of a limited number of discrete words and linguistic forms. Within any given person's brain, there'll be thoughts defined by patterns of neuron firings, and the crucial role of language is to provide a way to robustly package up those thoughts and, for example, represent them with discrete words so they can be communicated to another person and unpacked in that person's brain to produce neuron firings that reproduce what amount to those same thoughts. When we're dealing with something like a numerical measurement, we might imagine that it could have some kind of absolute interpretation. But words are much more obviously an arbitrary basis for communication. We could pick a different specific word, say from a different human language, but still communicate the same thing. All that's required is that everyone who's using the word agrees on its meaning. And presumably that normally happens because of shared social history between people who use a given word. It's worth pointing out that for this to work, there has to be a certain separation of scales. The collective impression of the meaning of a word may change over time, but that change has to be slow compared to the rate at which the word is used in actual communication. In effect, the meaning of a word, as we humans might understand it, emerges from the aggregation of many individual uses. In the abstract, there might not be any reason to think that there'd be a way to understand words consistently, but it's a story very much like what we've encountered in both physics and mathematics. Even though there are lots of complicated individual details underneath, we as observers manage to pick out features that are simple enough for us to understand. In the case of molecules in a gas, that might be the overall pressure of the gas. And in the case of words, it's a stable notion of meaning. Put another way, the possibility of language is another example of observer theory at work. Inside our brains, there are all sorts of complicated neuron firings, but somehow these can be packaged up into things like words that form human-level narratives. There's a certain complicated feedback loop between the world as we perceive it and the words we use to describe it. We invent words for things we commonly encounter, chair, table, and so on. Yet once we have a word for something, we're more able to form thoughts about it or communicate about it. And that in turn makes us more likely to put instances of it in our environment. In other words, we tend to build our environment so that the way we have of making narratives about it works well, or in effect, so our inner description of it can be as simple as possible, and it can be as predictable to us as possible. We can view our experience of physics and of mathematics as being the result of us acting as physical observers and mathematical observers. Now we're viewing our experience of the conceptual universe as being the results of us acting as conceptual observers. But what's crucial is that in all these cases, we have the same intrinsic features as observers: computational boundedness and a belief in persistence. The computational boundedness is what makes us equivalence things to the point where we can have symbolic description of the world, for example, in terms of words. And the belief in persistence is what lets those words have persistent meanings. And actually, these ideas extend beyond just language to paradigms and general ways of thinking about things. When we define a word, we're in effect defining an abstraction for a class of things. And paradigms are somehow a generalization of this, ways of taking lots of specifics and coming up with a uniform framework for them. And when we do this, we're in effect making a classic observer theory move and equivalencing lots of different things to produce an internal impression that's simple enough to fit in our finite minds. In the end, it's all just the Ruliad. Our tendency as observers is always to believe that we can separate our inner experience from what's going on in the outside world. But in the end, everything is just part of the Ruliad. And at the level of the Ruliad, we as observers are ultimately made of the same stuff as everything else. But can we imagine that we can point at one part of the Ruliad and say that's an observer, and another part and say that's not? At least to some extent, the answer is presumably yes, at least if we restrict ourselves to observers like us. But it's a somewhat subtle and seemingly circular story. For example, one core feature of observers like us is that we have a certain persistence, or at least we believe we have a certain persistence. But inevitably, at the level of the raw Ruliad, we're continually being made from different atoms of existence, i.e. different eames. So in a sense, in what sense are we persistent? Well, the point is that an observer can equivalence those successive patterns of eames so that what they observe is persistent. And yes, this is, at least on the face of it, circular. And ultimately, to identify what parts of the Ruliad might be persistent enough to be observers, we'll have to ground this circularity in some kind of further assumption. What about the computational boundedness of observers like us, which forces us to do lots of equivalencing? At some level, that equivalencing must be implemented by lots of different states evolving to the same states. But once again, there's circularity, because even to define what we mean by the same states, are isomorphic graphs the same and so on, we have to be imagining certain equivalencing. So how do we break out of the circularity? The key is presumably the presence of additional features that define observers like us. And one important class of such features has to do with scale. We're neither tiny nor huge. We involve enough eames that consistent averages can emerge, yet we don't involve so many eames that we span anything but an absolutely tiny part of the whole Ruliad. And actually, a lot of our experience is determined by our size as observers. We're large enough that certain equivalencing is inevitable, yet we're small enough that we can reasonably think of there being many choices for where we are. The overall structure of the Ruliad is a matter of formal necessity. There's only one possible way for it to be. But there's contingency in our character as observers. And for example, in a sense, there's a fundamental constant of nature as we perceive it, which is our extent in the Ruliad, say measured in eames, and appropriately project in the physical space, branch shield space, and so on. And the fact that this extent is small compared to the whole Ruliad means that there are many possible observers who can think of existing at different positions in the Ruliad. And those different observers will look at the Ruliad from different points of view and thus develop different internal impressions of perceived reality. But a crucial fact central to our physics project is that there are certain aspects of that perceived reality that are inevitable for observers like us and that correspond to core laws of physics. But when it gets to more specific questions, what does the night sky look like from where you are, and so on, different observers will inevitably have different versions of perceived reality. So is there a way to translate from one observer to another? Essentially, that's a story of motion. What happens when an observer that's at one place in the Ruliad moves to another place? Inevitably, the observer will be made of different eames if it's at a different place. But will it somehow still be the same? Well, that's a subtle question that depends both on the background structure of the Rulliad and the nature of the observer. If the Rulliad is too wild, think space-time near a singularity, then the observer will inevitably be shredded as it moves. But computational irreducibility implies a certain overall regularity to most of the Rulliad, making pure motion at least conceivable. But to achieve pure motion, the observer still has to be made of something that is somehow robust, essentially some lump of computational reducibility that can predictably survive the underlying background of computational irreducibility. In space-time, we can identify such lumps with things like black holes and particles like electrons and photons and so on. And yes, in our models, there's probably considerable commonality between black holes and particles. It's not yet clear quite what the analog is in branchial space, though a very simple example might involve persistence of qubits. And in Rullial space, one kind of analog is the very notion of concepts. For in effect, concepts, as represented, for example, by words, are the analog of particles in Rullial space. They are the robust structures that can move across Rullial space and maintain their identity, carrying the same thoughts to different minds. So what does all this mean for what can constitute an observer in the Rulliad? Observers, in effect, leverage computational reducibility to extract simplified features that can fit in finite minds. But observers themselves must also embody computational reducibility in order to maintain their own persistence and the persistence of the features they extract. Or in other words, observers must, in a sense, always correspond to patches of regularity in the Rulliad. But can any patch of regularity in the Rulliad be thought of as an observer? Probably not usefully so, because another feature of observers like us is that we are connected in some kind of collective social framework. Not only do we individually form internal impressions in our minds, but we also communicate those impressions. And indeed, without such communication, we wouldn't, for example, be able to set up things like coherent languages with which to describe things. What we assume about ourselves. So a key implication of our physics project and the concept of the Rulliad is that we perceive the universe to be the way we do because we are the way we are as observers. And the most fundamental aspect of observers like us is that we're doing lots of equivalencing to reduce the complexity of the world to internal impressions that fit in our minds. But just what kinds of equivalencing are we actually doing? At some level, a lot of that is defined by the things we believe or assume about ourselves and the way we interact with the world. A very central assumption we make is that we're somehow stable observers of a changing outside world. Of course, at some level, we're not actually stable at all. We're built up from eames whose configuration is changing all the time. But our belief in our own stability, and in effect, our belief in our persistence in time, makes us equivalence those configurations. And having done that equivalencing, we perceive the universe to operate in a certain way that turns out to align with the laws of physics we know. But actually, there's more than just our assumption of persistence in time. For example, we also have an assumption of persistence in space. We assume that at least on reasonably short timescales, we're consistently observing the universe from the same place and not, say, continually darting around. The network that represents space is continually changing around us, but we equivalence things so that we can assume that in a first approximation, we're staying in the same place. Of course, we don't believe that we have to stay in exactly the same place all the time. We believe we're able to move. And here we make what amounts to another assumption of stability. We assume that pure motion is possible for us as observers. In other words, we assume that we can go to different places and still be the same us, with the same properties as observers. At the level of the raw Rulliad, it's not at all obvious that such assumptions can consistently be made. But as we discussed before, the fact that for observers like us, they can, at least to a good approximation, that they can do this, at least to a good approximation, is a reflection of certain properties of us as observers, in particular of our physical scale, being large in terms of atoms of space, but small in terms of the whole universe. Related to our assumption about motion is our assumption that space exists, or that we can treat space as something coherent. Underneath, there's all sorts of complicated dynamics of changing patterns of EAMs, but on the timescales at which we experience things, we can equivalence these patterns to allow us to think of space as having a coherent structure. And once again, the fact that we can do this is a consequence of physical scales associated with us as observers. In particular, the speed of light is fast enough that it brings information to us from the local region around us in much less time than it takes our brain to process it. And this means that we can equivalence all the different ways in which different pieces of information reach us, and we can consistently just talk about the state of a region of space at a given time. Part of our assumption that we're persistent in time is that our thread of experience is at least locally continuous, with no breaks. Yes, we're born and we die and we also sleep, but we assume that at least on scales relevant for our ongoing perception of the world, we experience time as something continuous. More than that, we assume that we have just a single thread of experience, or in other words, that there's always just one us going through time. Of course, even at the level of neurons in our brains, all sorts of activity goes on in parallel, but somehow in our normal psychological state, we seem to concentrate everything so that our inner experience follows just one thread of history on which we can operate in a computationally bounded way and form definite memories and have definite sequences of thoughts. We're not as familiar with branchial space as with physical space, but presumably our fundamental assumption of stability extends there as well. And when combined with our basic computational boundedness, it then becomes inevitable, as we talked about before, that we'll conflate different quantum paths of history to give us as observers, a definite sort of classical thread of inner experience. Well, beyond stability, another very important assumption we implicitly make about ourselves is what amounts to an assumption of independence. We assume that we can somehow separate ourselves off from everything else. And one aspect of this is that we assume we're localized and that most of the Rulliad doesn't matter to us, so that we can equivalence all the different states of the rest of the Rulliad. But there's also another aspect of independence, that in effect we can choose to do whatever we want, independent of the rest of the universe. And this means we can assume that we can, for example, essentially do any possible experiment, make any possible measurement, or go anywhere we want in physical or branchial space, or indeed Rullial space. We assume that we effectively have free will about these things, determined only by our inner choices and independent of the state of the rest of the universe. Ultimately, of course, we're just part of the Rulliad, and everything we do is determined by the structure of the Rulliad and our history within it. But we can view our belief as freedom as a reflection of the fact that we don't know a priori where we'll be located in the Rulliad. And even if we did, computational irreducibility would prevent us from making predictions about what we will do. So beyond our assumptions about our own independence from the rest of the universe, there's also the question of independence between different parts of what we observe. And quite central to our way of parsing the world is our typical assumption that we can think about different things separately. In other words, we assume that it's possible to factor what we see happening in the universe into independent parts. In science, this manifests itself in the idea that we can do controlled experiments in which we study how something behaves in isolation from everything else. It's not self-evident that this will be possible, and indeed in areas like ethics, it might fundamentally not be. But we as observers tend to implicitly assume it. And actually, we normally go much further because we typically assume that we can describe and think about the world symbolically. In other words, we assume that we can take all the complexity of the world and represent at least the parts of it that we care about in terms of discrete symbolic concepts of the kind that appear in human or computational language. There's lots of detail in the world that our limited collection of symbolic concepts doesn't capture, and effectively equivalences out. But the point is that it's this symbolic description that normally seems to form the backbone of the inner narrative we have about the world. There's another implicit assumption that's being made here, however. It's that there's some kind of stability in the symbolic concepts we're using. Yes, any particular mind might parse the world using a particular set of symbolic concepts, but we make the implicit assumption that there are other minds out there that work like ours. And this makes us imagine that there can be some form of objective reality that's just always out there to be sampled by whatever mind might happen to come along. Not only, therefore, do we assume our own stability as observers, we also assume a certain stability to what we perceive of everything that's out there. Underneath There's all the wildness and complexity of the Roolead, but we assume that we can successfully equivalence things to the point where all we perceive is something quite stable and something that we can describe as ultimately governed by consistent laws. It could be that every part of the universe just does its own thing with no overall laws tying everything together. But we make the implicit assumption that no, the universe, at least as far as we perceive it, is a more organized and consistent place. And indeed, it's that assumption that makes it possible for us to operate as observers like us at all, and even to imagine that we can usefully reduce the complexity of the world to something that fits in our finite minds. The cost of observation. What resources does it take for an observer to make an observation? In most of traditional science, observation is at best added as an afterthought, and no account is taken of the process by which it occurs. And indeed, for example, in the traditional formalism of quantum mechanics, while measurement can have an effect on a system, it's still assumed to be an indivisible act without any internal process. But in observer theory, we're centrally talking about the process of observation. And so it makes sense to try asking questions about the resources involved in this process. We might start with our own everyday experience. Something happens out in the world. What resources and, for example, how much time does it take us to form an impression of it? Let's say that out in the world, a cat either comes into view or it doesn't. There are signals that come into our brain from our eyes, effectively carrying data on each pixel in our visual field. Then inside our brain, these signals are processed by a succession of layers of neurons, with us in the end concluding either there's a cat there or there's not. And from artificial neural nets, we get a pretty good idea of how this likely works. And the key to it, as we talked about before, is that there's an attractor. Lots of different detailed configurations of pixels all evolve either to the cat or no cat final state. The different configurations have been equivalents so that only a final conclusion survives. The story is a bit trickier, though, because cat or no cat really isn't the final state of our brain. Hopefully, it's not the last thought we have. Instead, our brain will continue to think more thoughts. So cat, no cat is at best some kind of intermediate waypoint in our process of thinking, sort of an instantaneous conclusion that we'll continue to build on. And indeed, when we consider measuring devices, like a piston measuring the pressure of a gas, we similarly usually imagine that they will come to an instantaneous conclusion, but continue operating and producing more data. How long should we wait for each intermediate conclusion? How long, for example, will it take for the stresses generated by a particular pattern of molecules hitting a piston to dissipate out and for the piston to be ready to produce more data? There are lots of specific questions of physics here, but if our purpose is to build a formal observer theory, how should we think about such things? There is something of an analogy in the formal theory of computation. An actual computational system, say in the physical world, will just keep computing. But in formal computation theory, it's useful to talk about computations that halt and about functions that can be evaluated and give a definite answer. So what's the analog of this in observer theory? Instead of general computations, we're interested in computations that effectively implement equivalences. Or put another way, we want computations that destroy information, that have many incoming states, but few outgoing ones. As a practical matter, we can either have the outgoing states explicitly represent whole equivalence classes, or they can just be canonical representatives, like in a network where at each step, each element takes on whatever the majority or consensus value of its neighbors was. But however it works, we can still ask questions about what computational resources were involved. How many steps did it take? How many elements were involved? And with the idea that observers like us are computationally bounded, we can expect limitations on these resources. But with this formal setup, we can start asking just how far an observer like us can get, say in coming to a conclusion about the results of some computationally irreducible process. An interesting case arises in putative quantum computers. In the model implied by our physics project, such a quantum computer effectively performs many computations in parallel on the separate branches of a multi-way system representing the various threads of history of the universe. But if the observer tries to come to a conclusion about what actually happened, they have to knit together all those threads of history, in effect by implementing equivalences between them. One could in principle imagine that an observer who just one could in principle imagine an observer who just follow all the quantum branches but it wouldn't be an observer like us, because what seems to be a core feature of observers like us is that we believe we have a single thread of experience. And to maintain that belief, our process of observation must equivalence all the different quantum branches. How much effort will that be? Well, inevitably, if a thread of history branched, our equivalencing has to undo that branching. And that suggests that the number of elementary equivalencies will have to be at least comparable to the number of elementary branchings, making it seem that the effort of observation will tend to be at least comparable to reduction of effort associated with parallelism in the underlying quantum process. In general, it's interesting to compare the effort of observation with the effort of computation. With our concept of elementary equivalencing, we have a way to measure both in terms of computational operations. And yes, both could in principle be implemented by something like a Turing machine, though in practice the equivalencies might be most conveniently modeled by something like string rewriting. And indeed, one can often go much further, talking not directly in terms of equivalencies, but rather about processes that show attractors. There are different kinds of attractors, sometimes as in class 1 cellular automata. There are just a limited number of static global fixed points, say either all cells black or all cells white. But in other cases, such as class 3 cellular automata, the number of output states may be smaller than the number of input states, but there may be no computationally simple characterization of them. Observers like us, though, mostly seem to make use of the fixed points. We try to symbolicize the world, taking all the complexities out there and reducing them to discrete conclusions that we might, for example, describe using the discrete words in a language. There's an immediate subtlety associated with attractors of any kind, though. Typical physics is reversible in the sense that any process, say two molecules scattering from each other, can run equally well backwards and forwards. But in an attractor, one goes from lots of possible initial states to a smaller number of attractor final states. And there are two basic ways this can happen, even when there's underlying reversibility. First, the systems one's studying can be open in the sense that effects can radiate out of the region one's studying. And second, the states of the system that the system gets into can be complicated enough that, say, a computationally bounded observer will inevitably equivalence them. And indeed, that's the main thing that's happening, for example, when a system reaches thermodynamic equilibrium, as described by the second law. And actually, once again, there's often a certain circularity. One's trying to determine whether an observer has finished observing and come to a conclusion, but one needs an observer to make that determination. Can we tell if we finished forming a thought? Well, we have to think about it, and in effect, by forming another thought. Put another way, imagine we are trying to determine whether a piston has come to a conclusion about pressure in a gas. Particularly if there's microscopic reversibility, the piston and things around it will continue wiggling around. It'll take an observer to determine whether the heat is dissipated to the point where one can read out the result. But how do we break out of what seems like an infinite regress? The point is that whatever mind is ultimately forming the impression that is the observation is inevitably the final arbiter. And yes, this could mean that we'd always have to start discussing all sorts of details about photoreceptors and neurons and so on. But as we talked about at length, the key point that makes the general observer theory possible is that there are many conclusions that can be drawn for large classes of observers, quite independent of these details. Okay, but what happens if we think about the raw Roolead? Now all we have are EAMs and elementary events updating the configurations of them. And in a sense, we're fishing out of this pieces that represent observers and pieces that represent things they're observing. Can we assess the cost of an observation here? It really depends on the fundamental scale of what we consider to be observers. And in fact, we might even think of our scale as observers, say measured in terms of EAMs or elementary events, as defining a fundamental constant of nature, at least for the universe as we perceive it. But given this scale, we can, for example, ask for there to develop consensus across it, or at least for every EAM in it to have had time to communicate with every other. In an attempt to formalize the cost of observation, we'll inevitably have to make what seem like arbitrary choices, just as we would in setting up a scheme to determine when an ongoing computational process has generated an answer. But if we assume a certain boundedness to our choices, we can expect that we'll be able to draw definite conclusions and in effect be able to construct an analog of computational complexity theory for processes of observation. the future of observer theory. So my goal has been to explore some of the key concepts and principles needed to create a framework that we can call observer theory. But what I've talked about here is just the beginning, and there's much still to be done in fleshing out the theory and investigating its implications. One important place to start is in making more explicit models of the mechanics of observation. At the level of the general theory, it's all about equivalencing. But how specifically is that equivalencing achieved in particular cases? There are thousands of kinds of sensors, measuring devices, analysis methods, and so on. All of these should be systematically inventoried and classified. And in each case, there's a meta-model to be made that clarifies just how equivalencing is achieved and, for example, what separation of physical or other scales makes it possible. Human experience and human minds are the inspiration and ultimate grounding for our concept of an observer. And insofar as neural nets trained on what amount to human experiences have emerged as somewhat faithful models for what human minds do, we can expect to use them as a fairly detailed proxy for observers like us. So, for example, we can imagine exploring things like quantum observers by studying multi-way generalizations of neural nets. And this is something that becomes easier if instead of organizing the data into real number weights, we can atomize neural nets into purely discrete elements. Some investigations of potentially realistic models provide a useful practical grounding for observer theory. But to develop a general observer theory, we need a more formal notion of an observer. And there's no doubt that a whole abstract framework, perhaps using methods from areas like category theory, that can be developed purely on the basis of our concept of observers being about equivalencing. But to understand the connection of observer theory to things like science, as done by us humans, we need to tighten up what it means to be an observer like us. What exactly are all the general things we believe about ourselves? As we talked about, many we so much take for granted that it's challenging for us to identify them as actually just beliefs that, as just beliefs that in principle don't have to be that way. But I suspect that the more we can tighten up our definition of observers like us, the more we'll be able to explain why we perceive the world the way we do and attribute to it the laws and properties we do. Is there some feature of us as observers, for example, that makes us parse the physical world as being three-dimensional? We could represent the same data about what's out there by assigning a one-dimensional space-filling coordinate to everything, but somehow observers like us don't do that. And instead, in effect, we probe the Roolead by sampling in what we perceive are 3D slices. And yes, the most obvious coarse graining just considers progressively larger geodesic balls, say in the spatial hypergraphs that appear in our physics project, but that's probably at best just an approximation to the sampling observers like us do. As part of our physics project, we've discovered that the structure of the three main theories of 20th century physics, statistical mechanics, general relativity, and quantum mechanics, can be derived from properties of the Roolead just by knowing that observers like us are computationally bounded and believe we're persistent in time. But how might we reach, say, the standard model of particle physics with all its particular values of parameters and so on? Some may be inevitable given the underlying structure of our theory, but others, one suspects, are in effect reflections of aspects of us as observers. They are derivable, but only given our particular character or beliefs as observers. And yes, presumably things like the constants of nature that characterize, the particular constant of nature that characterizes our size and eames will appear in the laws we attribute to the universe as we perceive it. By the way, these considerations of observers like us extend beyond physical observers. So, for example, as we tighten up our characterization of what we're like as mathematical observers, we can expect that this will constrain the possible laws of our mathematical universe. We might have thought that we could pick whatever axioms we want, in effect sampling the Roolead to get any mathematics we want. But presumably observers like us can't do this, so that questions like, is the continuum hypothesis true, can potentially have definite answers for any observers like us and for any coherent mathematics that we build. But in the end, do we really have to consider observers whose characteristics are grounded in human experience? We already reflexively generalize our own personal experiences to those of other humans. But can we go further? We don't have the internal experience of being a dog, an ant colony, a computer, or an ocean. And typically, at best, we anthropomorphize these things, trying to reduce the behavior we perceive in them to elements that align with our own human experience. But are we as humans just stuck with a particular kind of internal experience? The growth of technology, and in particular sensors and measuring devices, has certainly expanded the range of inputs that can be delivered to our brains. And the growth of our collective knowledge about the world has expanded our ways of representing and thinking about things. Right now, those are basically our only ways of modifying our detailed internal experience. But what if we were to connect directly and internally into our brains? Presumably, at least at first, we'd need the neural user interface to be familiar, and we'd be forced into, for example, concentrating everything into a single thread of experience. But what if we allowed multi-way experience? Well, of course, our brains are already made up of billions of neurons that each do things, but it seems to be a core feature of human experience that we concentrate those things to give a single thread of experience. And that seems to be an essential feature of being an observer like us. That kind of concentration also happens in a flock of birds, an ant colony, or a human society. In all these cases, each individual organism does their thing, but somehow collective decisions get made with many different situations getting equivalents together to leave only the final decision. So that means that from the outside, the system behaves as we would expect of an observer like us. Internally, that kind of observer behavior is happening above the experience of each single individual, but still at the level of the hive mind, it's behavior that's typical in an observer like us. That's not to say, though, that we can readily imagine what it's like to be an observer like this, or even to be one of its parts. And in the effort to explore observer theory, an important direction is to try to imagine ourselves having a different kind of experience that we do. And from within that experience, try to see what kind of laws we would attribute, say, to the physical universe. In the early 20th century, particularly in the context of relativity and quantum mechanics, it became clear that being more realistic about the observer was crucial in moving forward in science. Things like computational irreducibility, and even more so, our physics project, take that another step. One used to imagine that science could somehow be fundamentally objective and independent of all aspects of the observer. But what's become clear is that it's not, and that the nature of us as observers is actually crucial in determining what science we experience. But the crucial point is that there are often powerful conclusions that can be drawn even without knowing all the details of an observer. And that's a central reason for building a general observer theory, in effect to give an objective way of formally and robustly characterizing what one might consider to be the subjective experience in science. So that's what I wrote about observer theory. And I said at the end there, no doubt lots of precursors of varying directness that can be found for the things I was talking about. I haven't attempted a serious historical survey. I thought that would be an interesting thing to do. In my own work, chapter 10 of A New Kind of Science from 2002 is entitled Processes of Perception and Analysis, and really was for me sort of the precursor of these efforts. So let's see. Well, I'm happy to try and take, if I have a chance here, a few questions, perhaps. Mike asks, how does observer theory get us behind consciousness? Oh, let's see. Where does it meet it? Well, I think the question is sort of what's the essence of what's happening in consciousness? How is what happens in a brain different from what happens in generic computation? I think what I've increasingly realized is that we might have thought that consciousness was sort of the tippy top of all kinds of processes in the universe. But I don't think that's true. I think many processes in the universe are doing sort of arbitrarily sophisticated computations, but actually the things that happen in our brains are in some sense specific kinds of computations, in particular kinds of computations where we're doing the thing that is central to observer theory, which is we're taking sort of the complexity of the world and we're kind of crushing it down so that we believe we have a sort of single thread of experience. I think that's important to our kind of perception of consciousness. I mean, we can talk about the I mean, there's certainly a link between sort of the idea of consciousness and the kind of concept of observers. I think what I'm trying to do with observer theory is to essentially take a scientific slice of what we need to talk about consciousness, the scientific slice that we need to make conclusions about things, general things about how we perceive the world, rather than considering the internal experience of doing that. We're considering sort of what kinds of internal experiences can we have that we can kind of identify scientifically. Tori asks, would you say that an observer is made recursively by sub-observers? Oh boy, that's an interesting question. I mean, there's a certain circularity to an observer has to know that you have a thing that's an observer that's come to a conclusion about what they see. One sort of has to have another observer observing that. And I don't know whether I would consider that sort of a sub-observer. I think that for us, we have this series of distinct thoughts, and a thought doesn't have other thoughts inside it particularly. A thought, we at least feel, is like a thing unto itself. A word is a word. The word doesn't have other words inside it. So I think there's a sense in which there's sort of the question of defining the observer depends on sort of other observers. It's kind of a network of observers that all have to be consistent to define the notion of observer. But I would say that there is a sense in which there is a sort of a distinct kind of discreteness to the kind of notion of an observer itself. Let's see. Well, Soren is asking about the second law, which states that the entropy is increasing along with the expansion of the universe that will lead to the death of everything. Well, let me just say one thing quickly about that, which relates to observers. You know, the second law essentially is saying that the configuration of molecules that we get, we can't recognize as being ever anything different from random. Even though in reality, there is a precise configuration of molecules that we could reverse the dynamics on and get back to whatever initial condition we had. But the point is that observers like us can't do that. So for example, when we think about the future of the universe and sort of the idea of the heat death of the universe, there is a configuration of molecules that is the universe today. Its distant future might be something in which those molecules are bouncing around in some particular way, which to observers like us today looks like random heat. But we can certainly imagine observers who would notice, oh, those molecules are configured in this or that particular way. That was the thing which was the result of what happened in 2025, and now we're 1 trillion years later on, and this is how things played out from that. Observers like us, who are computationally bounded, for example, we can't recognize all that stuff. 1 trillion years from now, we'll never be able to invert the computation to say that was what happened in 2025. But it isn't to say that information is not there. It's there, but not to observers like us. So the story of the second law and these phenomena like the heat death of the universe is really a story of observers like us and a story of the fact that observers like us believe that the best we can do is to say things got more random or entropy increased. So in the traditional sort of treatment of the second law, by the early 20th century, people were talking about coarse graining and the idea that this precise details of molecules, you sort of couldn't see that. And there was some kind of notion of that the things you could prepare or observe about gases were coarse-grained versions. That was never very well defined. What was a valid coarse graining? Why couldn't you have a coarse graining that very particularly picked out the particular things that happen in a gas of this or that kind? What this kind of computational point of view and observer theory kind of gives one is a way to be more formal and precise about what it means to what kinds of coarse graining are conceivable coarse grainings, because it tells you that the coarse grainings that you can do are ones that correspond to computationally bounded observers. And that means that you actually have the chance to really prove something about the fact that the dynamics of molecules is doing enough irreducible computation that's sort of encrypting the initial condition to the point where observers like us, with our computational boundedness, can't decode it. So it's no longer just, oh, well, there is this coarse graining. We have to kind of be vague about what that means. It's the coarse graining is associated with the fact that observers like us have this very particular property of being computationally bounded. Let's see. Sandeep asks, it's not clear when I'm saying that do humans, or for that matter, everyone in the universe sample the R'lyad in the same way, or does every individual sample it differently? So I think every mind is effectively at a different place in the R'lyad. Minds can communicate by essentially sending signals, sending things like particles, things like concepts, which are sort of the analog of particles in R'lyal space, from the position of one mind in the R'lyad to the position of another mind. So just as human minds occupy in physical space different places, so also they occupy different places in R'lyal space. They have different views of the rules that govern the universe because they're configured in different ways, their brains work differently, and so on. So the idea is that that every mind is at a different place in R'lyal space. Human minds, particularly ones with sort of common backgrounds, are pretty close together in R'lyal space. You can move in R'lyal space by kind of changing your way of thinking about things. But this is, every mind is at a particular place in R'lyal space. So human minds form this little clump somewhere in R'lyal space. Cat minds, dog minds form other clumps. And this question, the interesting thing is because the clump, the flock of human minds in R'lyal space is very tightly, is very sort of tight relative to all of R'lyal space. There are many things about the universe that we all kind of agree about how it works. We all kind of agree that space is three-dimensional, for example. That's in a sense because we are tightly clumped in R'lyal space. If we could imagine if there was another mind that was far, far away that thought about the universe in a different way, it might think about the universe as one-dimensional, or it might think about something very differently. The thing is that as a practical matter, as a matter of historical contingent, we are all close together in R'lyal space, just as we are all relative to the span of the universe, close together in physical space. And I think that's, if we imagined an entity far away in R'lyal space, its perception of the universe would be very different. Its laws of physics, its perceived laws of physics might be very different. The problem is it's very hard for us to communicate with something far away in R'lyal space. It's hard enough to communicate with something far away in interstellar space and physical space. It's harder, perhaps still, to communicate with something that is far away in R'lyal space, that has a very different way of thinking about the way the universe works and so on. It's sort of, that's in a sense, the problem of searching for extraterrestrial intelligence is not just, are the extraterrestrials sort of nearby in physical space, but also how far away are they in R'lyal space? And systems that are far away in R'lyal space, we'd look at them and say, well, they're doing something complicated. We don't really know what it is. Are they really intelligences? Well, unless they're close enough in R'lyal space that we can kind of align our way of thinking about things with their ways of thinking about things, we won't identify them as being intelligences like us. And I think that's sort of the fundamental feature of extraterrestrial intelligence, is there are lots of physical processes in the universe which are complicated and which are kind of as complicated as the kind of the nerve firings in our brains, but which we don't identify as being sort of aligned, close enough to us in R'lyal space, aligned with us in what they do, to be able to say that this is an intelligence like us. Super Crunch says, show love to the observer. Well, yes, I should thank you all for being observers of my efforts to understand observers. Yao asks, why do observers exist? That's a very good question. I think The interesting thing about the Rulliad is the Rulliad necessarily exists. Once you have the idea of computation, the Rulliad is an inevitable construct and a unique construct. Now, why should observers like us exist within the Rulliad? It would be nice to be able to prove that observers like us must exist within the Rulliad, to prove as a matter of science that we must exist. It gets very theological very quickly because in a sense, the Rulliad is out there necessarily existing. People have often talked about, is there a necessary being, which they would identify at different times with God or various other kinds of things like that. And it's kind of the Rulliad is a necessary thing. What is contingent is our existence within that. And as I say, the thing that's sort of exciting about thinking about the Rulliad and thinking about these things computationally is one might imagine that one could just outright prove that somewhere in the Rulliad there must be observers like us. What would it take to do that? Well, one feature of observers like us is there are lots of us. If there was just one of us, one mind, then it would be hard. Many of the things that we kind of think about the universe and so on wouldn't really have the same grounding if there was just one mind. We have a sort of collective way of thinking about things where we convince each other that there is an objective reality, that we're all seeing the same things, that there is something to discuss about objective reality. If there was just one mind in the universe, we wouldn't really have that option. So one of the things that's interesting, I think, and surprising about observers like us is there are lots of us. And so the question of whether there inevitably have to exist observers like us with lots of us starts reflecting on things that seem very specific, like ideas about life and self-reproduction and so on. Self-reproduction is important because it makes a bunch of observers that are all kind of the same. And although not exactly the same, they start from the same place, but then their minds can evolve differently. So I kind of think that the very interesting thing that again, more progress needs to be made on is this question of can one prove that within the Rulliad there inevitably will be sort of constructs that have certain forms? I'm sure the answer is yes, but making that proof will be a very interesting thing to do. And by the way, if you make that proof, kind of the bonus point is you might get to understand the density of such objects in the Rulliad, or in effect, the density of extraterrestrial intelligences or extra, I don't know what one calls it, extra mental intelligences or something that are away from, that it's kind of the density in Rullial space of intelligences or of things that are observers like us, so to speak. So that's the thing that will be the big bonus point in being able to derive our existence from all of this, is that we might be able to know the density of the existence of things a bit like us. But yes, it's a very good question. Why do observers exist? That is something that can be scientifically addressed. And I sort of started poking around at that, although I can't say I've solved it. Again, I think it enmeshes quite a lot with things about the origin of life, the idea of self-reproduction and so on, which I hadn't expected. I had thought that a question like why do observers exist is a question that would be sort of not as specific as to start talking about things like life and self-reproduction, but I think it actually does entangle with this. Let's see. Brady is asking, so an ocean is not an observer because it's not equivalencing anything. I think that observers like us, it really is important to brains that we conclude definite things about what to do. I realized recently that the first things that had brains in the history of biology were when animals were around. Plants that just sit in one place don't have brains in the same way. As soon as you have an animal that's got to move around, the animal is in a definite place. It walks left, it walks right, it walks forwards, it flies up and down, whatever. It's in a definite place. And so one thing that has to happen is it takes all that sensory input, millions of different senses that it might have, and somehow it has to decide, because it needs to be in a definite place. So it has to take all that sensory input and it has to say, I'm coming up with a definite conclusion. I'm going to turn left. And so that phenomenon that was sort of born of the idea of animals and the idea of things that were living that could move around, I think that idea is what led to this notion of a single thread of experience that we have, which to us seems like it couldn't be any other way. But in a sense, it's a consequence of the fact that we had to make definite decisions, and now that's a thing that I think is specific. That's a thing that needs to be true to have an observer like us. And so I don't think something like an ocean, I haven't really thought that through properly, but I don't think that has that same kind of concentrating down of things in, into sort of a definite conclusion. One part of the ocean gets to a different thing than another part of the ocean. Just like one part of our brain is thinking about one thing, another part of our brain is thinking about another thing. It's, but in the end, let's say one says a definite thing. One part of my brain might be thinking about the fact that it's getting close to dinner time or something. Another part of my brain might be thinking about some other thing about the computer system that I'm sitting in front of or something. But in the end, I'm going to say some definite word next. And that's how brains like ours work. Let's see. Yeah, asks, so everything is just the execution of instructions. Are we inside a while true kind of programming construct? I think at some level we are. And I think that at some level we do definite things. We have, 250 actuators or something of our fingers moving and our voice box moving, our vocal cords moving, and so on. And, we send signals, we make definite things happen. That's the stream of instructions that we are imposing on the world. And although we get lots of sensory input, in the end, it's all turning into the what we do next type series of things, which I suppose one could think of as a pretty discrete series of instructions. I mean, I think we're going to understand this better as we get towards kind of really smooth humanoid robotics, really connected to good sort of AI-ish things. I think we'll have more of an intuitive sense of what's going on there, of the stream of sensory input going through to the stream of instructions about move this finger this way and so on. Let's see. EJ asks, does the observer necessarily have to be conscious, or could an observer ultimately be viewed as a representation, a model of measurement? Let's see. This question of, okay, ultimately what matters to us is what we perceive. We have devices, measuring devices, that sort of prep what it is we'll receive. We could receive the raw data. Let's say we're measuring the pressure of a gas. We could receive, on our fingers or something, the raw data of what, how all the molecules are moving around. But rather, we have a measuring device that aggregates that for us, and just as a pressure gauge that has some sort of display or something on it. So I think that it's kind of this idea of concentrating things down to get a definite answer. This is all a story of observers. Whether those observers, in the end, those observers are implemented in our brains, but we can absolutely prep them with measuring devices. And so it is an important thing that measuring devices go from the complexities of the world to individual numbers about what the pressure of something is, or some such other thing. So I think it's really the same kind of thing. And with measuring devices, they're a bit easier than brains to take apart and see how the measuring device really works. And yes, that's a perfectly reasonable thing to be studying. And that's a thing to which this observer theory that I'm talking about, with all these notions of equivalencies and so on, applies. Let's see. I don't understand this last comment that I have listed here from Acetatum. Since the future is our audience, does it have any effect on us? Oh, I see. I see. Let's think about that. So if the future is what will receive the effects, the things we do will play out in the future. The decision to do a particular thing will have consequences for the future. How much, how little, who knows? But the event that happens now will have consequences in the future. And there's sort of a question, I suppose, of how to think about the consequence, what that thing that happens in the future, how will it play back on what happens to us now? I'm somewhat reminded of the movie Arrival. Okay, there's a bit of a spoiler for people who haven't seen it, which I happened to do some consulting on a decade or so ago when it was being made. That has kind of a notion of critters, spoiler alert, that whose view of time is different from ours. And instead of thinking of time as something where we progressively kind of live into the future, it's a notion that sort of that all of time is laid out before us. And so in a sense, our future can affect our past because we're thinking of all of time laid out before us. It's kind of an interesting thing when we think about the Rulliad. The Rulliad is this necessary object that has all of these computational processes in it. And we normally think about ourselves as kind of progressing through time. Time, as far as I'm concerned, is the progressive doing of computation in the universe. The passage of time is the progression of computation in the universe, the computing of the next state of the universe from the previous one. That's what the progression of time, the passage of time is. That's our usual impression. But with the Rulliad is a bit strange because the Rulliad, we say the whole thing is just a necessary object. So in a sense, all of time already exists in this thing that is the Rulliad. So how is that consistent with our impression that we only progressively uncover the future? Well, the thing is that the way we can think about it is it's a computationally bounded observer story. Because yes, the whole Rulliad is out there. There is a sense in which all of time already exists in the Rulliad. However, as computationally bounded observers, we only get to crawl one little tiny bit through the Rulliad, as that our sort of computational boundedness prevents us from sort of sweeping out and seeing much more of the Rulliad. We're stuck observing little tiny pieces of the Rulliad. And that's the sense, that's a sense in which we can think about the progress of time, is it already all exists. And we're just crawling through it one step at a time, you might say. That's one view. The other view is we build the future progressively as by doing computation. So in other words, instead of thinking of the Rulliad as already existing, we think of it as being created by the actual doing of computation. These are equivalent views, you know, in physics, in sort of quantum physics and so on. These will be like the Schrodinger picture and the Heisenberg picture of quantum mechanics. That's not particularly useful unless you happen to know that formalism. But it's kind of a question of what's changing, the world or the observer, so to speak. And that's sort of the correspondence between those things. But it's so in that sense, the sort of what is now and what is the future is inevitably connected. And it's a deterministic thing in a sense, what the future is. And so you could say, well, the future affects the past because look at that thing in the future. We can know from that thing in the future what must have happened in the past. For example, you know, if you see the thing that, you know, a thing that's smashed on the floor, you can say, well, it's pretty likely that, you know, you see some light bulb, if those even exist anymore, that sort of fell on the floor and smashed. You could say, well, that probably its past was that it, you know, that was its future. Its past was it must have fallen and broken. So just as one might say as well, you know, if we see this thing, we're dropping this thing, we can say we predict its future, it will do this or that. But I think so. There's always this question. It's a tricky philosophical question. The question of whether things happen because of the mechanism by which they happen, or whether things happen because they achieve something, they achieve a purpose by happening. This is something that comes up a whole bunch in biology, a little bit less in physics, although it does happen in physics as well, because in physics, we can say there's a law of motion, Newton's law, something like this. there's an alternative formulation that came 150 years after Newton's laws, which is the principle of least action, which says, instead of just saying at every moment the thing moves according to forces that are applied to it, it says the whole motion of the thing will be such that it minimizes or extremizes this action object, which is some calculable thing, something that represents some feature of motion. So that's by saying it is trying to achieve the least action. That's an alternative to saying it is doing what it does because it was poked by these forces. There's a version of the principle of least action, which is the principle of least time for light. Light goes through the path that takes the least time. That is one way of describing it. Another way of describing it is, oh, the photons have this momentum and they're sort of deflected in this way, and they go in this way according to a mechanism. And in the case of light, those are sort of a little bit equal. You know, they're both reasonable formalisms. And I would say in physics as well, the least action principle is useful for some things. The other one is sort of the more elementary approach. But this question of what thing that happens is best described by mechanism, and what is best described by purpose. And I think that's an interesting thing. I wrote recently about sort of the meta-engineering that you can do from the game of life cellular automaton, its 50-year history and so on, where it's sort of a question of whether you say, this weird configuration that we got here is this way because somebody figured out they would do this cool thing, or is it this way because we just ran the search and this is what came out? Or is it this way because it achieves a certain purpose, or is it just this way and it's going to do certain things? And, you know, in biology, there's a great tendency as a result of kind of theory of natural selection and so on to say, you know, the beak of the finch is that shape because it, you know, is good for poking out this kind of fruit or something, where instead of the beak of the finch is that shape because some diffusing morphogen caused the growth process for the beak to do this or that thing. And I think it's an interesting thing. I've just been thinking about it recently, kind of the comparison between explanations by purpose and explanations by mechanism, which is somewhat similar to sort of asking how much does the future affect the past. An explanation by purpose is like saying what you're talking about the thing in terms of what it will achieve, so to speak. I mean, I think you know, Aristotle had this, who liked making lists of things, had these lists of causes, and had this kind of idea of final cause, you know, the teleology, the purpose of the thing, as opposed to its what are the others, the formal cause and things, the form of the thing, but more this sort of this comparison between mechanism and purpose as a way of explaining things. And it's been difficult because mechanism is something we really get to explain in terms of, we get formalizations of mechanism, you know, computational rules, formalized mechanism. It's been difficult to compare purpose and mechanism because we haven't had a good way to formalize purpose. And actually, I've sort of tried to understand how one would do that using essentially the kind of symbolic language ideas, computational language ideas from Wolfram language and so on. I think we're getting closer to being able to reasonably generally formalize purpose. And by the way, that's not completely unrelated to observer theory, because observer theory has to do with, so what did you actually get in the end? And that's quite related to the question of what did you want to get out of it in the end, so to speak. But I think that will allow us, it's a formalism still has to be built, that will sort of allow us to make comparisons of explanations by mechanism, explanations by purpose, and we'll be able to say things like, in this particular case, with this configuration of pixels or whatever, this is more succinctly explained by purpose than it is by mechanism. Now, needless to say, the language of explaining by mechanism will have to be compared to the language for explaining by purpose. You know, in what I imagine, there'll be sort of the same language, but one will be using, one's descriptive elements will be different for mechanism and purpose. But so one gets to be able to ask questions like, did this seem like it was made on purpose? because its description in terms of purpose is much smaller than its description in terms of mechanism? Or did this just happen? And so it is really described in terms of mechanism. So that's a few thoughts about kind of the sort of thinking about the future, so to speak. All right, maybe one last comment question here. Harry asks, so the Rulliad, is it finite or infinite? It is countably infinite. So it's like the integers. It's like there are an infinite number of integers, but you can distinguish every integer. Unlike the real numbers, where it's kind of where you can go in between any two real numbers, there's another real number. It's got a different level of infinity. But the Rulliad is a countably infinite object. Let's see. So I think the questions here about is what one's talking about with the Rulliad and so on some strange and scientified form of religion? That's an interesting question. I think what is kind of intellectually sort of exciting about some of these things is that there have been a certain set of questions that one has been able to address with science, with modern science, as it's evolved since the 1600s. There were plenty of questions that already existed that have been discussed by theologians for, a couple of thousand years before modern science came along. Modern science said we can do these particular things. And so those are the things that got concentrated on and were the things that allowed us to build technology, all those kinds of things. But it is interesting that with the developments that we have in science now, kinds of things I've been trying to think about, we get to go back to some of these questions that got asked by theologians for a long time and maybe have some scientifically relevant things to say about them. I think it's a question of sort of religions tend to have both sort of deeper philosophical points and what one could perhaps crassly call sort of a retail presence, so to speak. And I think that's this is on the deeper philosophical side. But if you ask questions like sort of our place in the universe and the purpose of the universe and things like this, those are things for which we have something scientific to say. Now, how does it affect the leading of one's life that that one can think about the Rulliad and one can think about sort of the space of all possible minds and so on? I'm not sure. I've wondered about that quite a bit. In other words, what things, should one lead one's life differently given that one knows these things about the world? I think the one conclusion that I would come to, which is more of an intellectual conclusion, is that there are deep foundations of things. It is worth thinking foundationally about things because there are deep foundations of things. Things are not just the way they are because they happen to be that way. The things are the way they are because there are deep foundations that lead them to be that way. And I think that that's a sort of a life lesson from some of the science, is it's worth trying to think foundationally about things, which is not something that, for example, in many cases, sort of modern education tends to sort of direct things in these very specialized, specific areas. And that tends to be sort of the antithesis of foundational thinking. And I think that one of the things one learns from the science is that there really are deep foundations, and it's worth thinking about things in a foundational kind of way. I think I will tell some silly story perhaps to end, which is we're visiting some country with a couple of my kids, and this is a country where in the the immigration or the entry sort of information, you have to fill out, among other things, you have to fill out religion. And so I was considering checking the box that said animism. And my kids said, don't do that. We'll be stuck for hours, in passport control if you do that. So I didn't do that. But I think it's an interesting thing when one sort of, again, I don't really know how, one of the things about sort of religions is they suggest things about how to lead one's life. I have strong opinions about that, but I don't think they're derived specifically I don't think they derive from kind of the sort of philosophy that I've understood from thinking about sort of these foundational questions about the way the world works. I mean, I have to say that one of the things that perhaps is an irony in my life is that these things that I talk about the Ruliad and about sort of the computational foundations of everything are in a sense deeply deconstructive of the world. They're taking sort of the particulars of they're trying to generalize far, far away from the particulars of our human existence, so to speak. And for a while, I was kind of like, it's surprising because as a person, I'm a person who finds people interesting. I'm sort of into the idea of people. And yet in science, I seem to be doing these things that are coldly not considering the people involved, that are coldly thinking about sort of the raw science in a way that's deeply deconstructed from the particulars of kind of human experience. But the irony for me is that having built all of that science that's sort of deeply deconstructed and sort of very general and austere, it's turned out in recent years that that I've realized that the observer, that's us, is actually critically important to those things which I had thought were just pure austere science, like the laws of physics and so on, that I've realized that actually it isn't true that the laws of physics are cold and austere and very non-human. The laws of physics critically depend on the fact that it's humans who are perceiving them. And so in a sense, even though I had thought, it's kind of one of my principles about doing science is to kind of let the chips fall as they do. Even if one has the prejudice that humans are a significant thing, you just do the science. And if the science is kind of leading you in a direction where humans aren't important, well, you do that anyway. And it's sort of been an interesting irony in my life, at least, that in the end, from having built this thing that is sort of austere, deconstructed science, one comes back to realizing that actually us humans really are more important, really are critically important, even in thinking about that austere kind of way of talking about science. And it is certainly an interesting question about sort of the relationship to theology and religion and so on, the extent to which these sort of philosophical conclusions map onto things that people have been saying for thousands of years. And I would say that I have found that interesting to study. It is so difficult. The sort of relationship between the things that I think about and the kind of historical antecedents and relations is difficult for me. I mean, in terms of raw science, I have often studied scientific history, whether it's about the second law of thermodynamics or something else. That history is hard in and of itself, but it has a certain definiteness to it. You can just say, this person observed this gas, wrote down this formula, and so on. It has a way of being anchored. I found the history of philosophy vastly more difficult, and the history of kind of religious thought also more difficult, because one's really dealing with things where instead of being able to say, well, they wrote down this formula, it's like, well, they had this statement made in a language that I don't know that seems to roughly say this, that in their way of thinking about things 2,000 years ago might have resonated in this way, but in our way of thinking about it today, it feels completely different in what's being said. And so I found it very difficult to really feel confident in sort of talking about how the things that I'm thinking about relate to things that people have thought about in those ways before. And it doesn't help that one grows up in a certain, in my case, in sort of a standard Western kind of tradition. And there are things which to other people are sort of obvious because they grew up in that tradition. It takes a big effort to kind of, map one's mind into those kinds of things, even if in fact the science that one's built, which I feel I understand reasonably well, might have sort of resonances with those kinds of things. And okay, we should probably wrap up there, but thank you for being here, and I look forward to talking about other things at another time. Thanks so much, and bye for now.
In the cold dawn of February 17th, 1600, a man was led to Rome's Campo dei Fiori. His tongue bound by an iron spike, his naked body chained to a stake, he faced the gathering crowd with unflinching resolve. As flames engulfed him, consuming flesh but not spirit, Giordano Bruno became immortal, not in body but in mind. They burned him for daring to imagine an infinite universe, for challenging the geocentric model of the Church, for suggesting that countless worlds might exist beyond our own, for questioning dogma with the dangerous weapons of reason and observation. Like Christ before him, Bruno died for the truth, crucified not on wood but in fire, refusing to recant his vision even as the flames rose higher. "Perhaps you pronounce this sentence against me with greater fear than I receive it," he told his inquisitors. His last act of defiance was turning his face away from the crucifix, offered for final comfort. Today we enter the mind of this extraordinary Dominican friar turned cosmic philosopher, a man whose ideas were so revolutionary, so threatening to established order, that the powers of his time could respond only with fire. This is not another story of persecution. It is the chronicle of a mind that broke free from the prison of medieval thought, soaring beyond the celestial spheres to capture the infinite. Bruno's philosophy, drawing from ancient wisdom, Arab scholars, Renaissance thinkers, and his brilliant intuition, forms one of the most remarkable cosmic visions ever conceived by human consciousness. Why should this matter to you now, centuries later? Because Bruno's battle, the struggle between dogma and free inquiry, between comfortable certainty and uncomfortable truth, continues to this day. His courage inspires all who dare to think beyond accepted limits. His vision of an infinite universe inhabited by countless worlds anticipated modern cosmology by centuries, and his tragic fate reminds us of the price some have paid for the intellectual freedom we now take for granted. I am Irevelato, your guide through the labyrinth of forgotten wisdom and dangerous ideas. I reveal the secrets you deserve to know, the lives and stories of luminaries and gods. Together we'll walk the path Bruno walked, tracing the sources of his revolutionary philosophy, understanding the mind that dared to reimagine the cosmos, and witnessing how one man's vision could threaten the foundations of an entire world order. Let me speak plainly for a moment. Our world is drowning in triviality. Our minds are dulled by endless entertainment and hollow content. What we do here matters. Bruno gave his life for the freedom to think, to question, to imagine beyond what tyrants couldn't understand. The least we can do is honor that sacrifice by continuing to explore the depths of human thought together. I don't create these journeys for algorithms or fame or money. I create them because these stories, these lives, deserve to be remembered. Because somewhere, right now, someone is searching for truths just as Bruno was. If that someone is you, then this channel is your sanctuary, your Campo dei Fiori, where ideas are not burned but illuminated. Subscribe not for me, but for what we're preserving together. The legacy of those who dare to think differently. Join a fellowship of minds that refuses to settle for comfortable, noble lies when uncomfortable truths await discovery. Now, let us turn to the extraordinary sources that shaped Bruno's cosmic vision. The ancient traditions, forgotten texts, and brilliant contemporaries who provided the raw materials from which he forged a philosophy that would ultimately cost him his life, yet outlive his executioners by centuries. What follows is a narration of Giordano Bruno by J. Lewis McIntyre, Part 2, Philosophy of Bruno, Chapter 1, The Sources of the Philosophy. In the school and the monastery at Naples, Bruno passed as a matter of course through a training in the scholastic philosophy. Before entering the monastery of St. Dominic at 15 years of age, he had studied humane letters, logic and dialectic, and had attended, among other lectures, a private course by Theophilus of Verano, an Augustan monk and distinguished Aristotelian. From him, probably, Bruno received an impetus towards the study of Aristotle, in the original works, if not also in the original tongue, which stood him in admirable stead when he came later to attack the foundations of the vulgar philosophy. He was familiar at first hand with all the main writings of Aristotle. He had read too, and cites, most of the earlier commentators, Adrastus and Alexander of Aphrodisias, Porphyry, Themistius, Simplicius, and Philoponus, as well as the later, the Arabians and other schoolmen. He had accordingly a more thorough acquaintance with the mind of Aristotle, prevented him, however, from taking a just view of the system as a whole. It was not the Aristotle of Greek philosophy whom he rejected, and against whom he wielded the powerful weapons of his armory, but the Aristotle of his own day, a living force with which no one could avoid a reckoning, the influence of which was no longer for good, but which formed, as Bruno felt, a barrier against the progressive thought and spirit of the time. In the introductory letter to the Figuratio Arist, Phys Auditus, Bruno gave 3 reasons for undertaking the work. 1, that he might not appear like so many others, to be taking up the office of censor without a sufficient knowledge of his subject. 2, that he might present to his opponents the philosophy of Aristotle as it really was, for the majority of the Aristotelians admired it rather from their faith in the man Aristotle than from discriminate judgment concerning the principles of the philosophy. 3, that he might seem not an audacious caviller against thoughts that were beyond his depth, but a genuine and legitimate disputant on doctrines that were clear to himself. The name of Aristotle was a charm. His opinion final not in matters of pure philosophy alone, but equally in natural theory. His natural philosophy had been harmonized with scriptural authority, and was the accepted doctrine of the Church. The cry which his critic heard had weight behind it. You against Aristotle, against so many authorities, so great names, I would rather be in error along with them than find truth with you. The danger lay not so much in the error of Aristotle's theory of nature, or of his metaphysical theories, as in his authority. Many of the peripatetics, Bruno says in the Scena, grow angry and flush and quarrel about Aristotle, yet do not understand even the meanings of the titles of his books. It was the influence of this authority that Bruno, in the interests of true philosophy and science, set to work to undermine. The charge which he brought against Aristotle was the same as that which Bacon afterwards brought, that he attempted to explain nature by logical categories. It is not strange that from impossible logical and imaginary distinctions, quite discordant with the truth of things, he infers an infinite number of other untruths. Inconvenientia. Matter is formless only to logical abstraction, as with Aristotle, who is constantly dividing by reason what is indivisible according to nature and truth. A logical intention or concept is made into a principle or element of nature. However unfair and indeed absurd the charge must appear when Aristotle is considered in his actual place within the development of philosophy and science, and however far Bruno or Bacon or any of the nature philosophers of the Renaissance was from avoiding the use in explanation of similar purely logical or metaphysical conceptions, it was still a great and necessary step to call attention to the need of observation and experiment upon nature, and to the value of mathematics as a method of calculating and correlating the phenomena observed. This was a second objection to Aristotle, that he despised mathematics, being too much of a logician and stronger in criticism than in argument. Yet Bruno adds, when he sought to explain any of the more profound facts of nature, he was often driven by necessity to the repudiated mathematics. Many of Bruno's own mathematical applications savour rather of Neo-Pythagorean mysticism than of the spirit of modern science, and his geometry was far from Euclidean, but he at least made a serious attempt to account for the building up of bodies and of the universe on mathematical principles. A third objection, which again we find in Bacon, is as to Aristotle's treatment of his predecessors. His depreciation of them is condemned in the Causa. Of all philosophers, I do not know one who founds more upon imagination or is further removed from nature than he, and if sometimes what he says is excellent, we know that it does not spring from his own principles, but is always a proposition taken from other philosophers. In another passage, he is described as a dry sophist, aiming with malicious explanations and frivolous arguments to pervert the opinions of the ancients and to oppose the truth, not so much perhaps through imbecility of intelligence as through the influence of envy and ambition. So Bacon speaks of him as imposing innumerable fictions upon the nature of things at his own will, being everywhere more anxious as to how one should extricate oneself by an answer, and how some positive reply in words should be made, than as to the internal truth of things. In particular, it was argued that Aristotle confused the various meanings of the same name with one another. He takes the word vacuum in a sense in which no one has ever understood it, building castles in the air and then pulling down his vacuum. But not that of any other who has spoken of a vacuum or made use of the name. So he acts in all other cases, those, for example, of motion, infinite, matter, form, demonstration being, always building on the faith of his own definition, which gives the name a new sense. The close study of Aristotle himself, which was one of the greatest results of the humanist movement, had the effect of bringing into greater prominence the earlier Greek philosophers, whose doctrines Aristotle states and criticizes in many of his works, notably the physics and metaphysics. The rediscovery of antiquity included that of ancient philosophy, and Bruno's dissatisfaction with Aristotle led him into greater sympathy with the nature philosophers, whom Aristotle decried. Towards these earlier Greeks, as towards other philosophers, his attitude is wholly that of an eclectic. He does not attempt to appreciate their relative value, nor to discover any evolution of thought through the successive systems. From each he takes that which agrees or appears to agree with his own philosophy, and treats it as an anticipation of, or as an authority for, the latter. The universal intelligence, for example, as the universal efficient cause in nature, is a doctrine ascribed in the Causa indiscriminately to the Pythagoreans, the Platonists, the Magi, Orpheus, Empedocles, and Plotinus. The belief in an infinite ether, Heraclitus' fire surrounding the earth, and containing innumerable worlds within it in the Sena, is attributed equally without discrimination to Heraclitus, Democritus, Epicurus, Pythagoras, Parmenides, and Melissus. Xenophanes represented for Bruno the static aspect of pantheism, the absolute one as in itself, apart from all reference to the finite. Heraclitus, its dynamic aspect, the absolute as unfolding, revealing itself, appearing in and through the finite. Anaxagoras expressed the relation between the finite individual and the one. All things are in all things, for omnipotent, all-producing divinity pervades the whole. Therefore nothing is so small, but that divinity lies concealed in it. Everything is in everything, because spirit or soul is in all things, and therefore out of anything may be produced anything else. To Anaxagoras, as to Bruno, nature was divine. No special distinction was made by Bruno between the teaching of Anaxagoras and that of Empedocles. In one passage he attributes to the former the theory of effluxes and influxes of atoms through the pores of bodies, which really belongs to the latter, and in another suggests that Empedocles only put in a more abstract way what Anaxagoras had shown concretely, that all things are in all. With Leucippus and Democritus, Bruno might have been expected to claim affinity through their common atomism and naturalism. With two cardinal features of the traditional Epicureanism, he was, however, in entire disagreement. The one was its admission of the void, or vacuum. It explained the constitution of diverse bodies out of atoms which were all of the same spherical form, by the different positions and order in which the void and solid parts respectively were arranged, whereas Bruno could not imagine the corporeal atoms holding together without a material substance, extending continuously throughout the universe. The other point of contrast was its denial that anything but corporeal matter exists, with the corollary that forms are merely accidental dispositions of matter. Bruno confesses to have been at one time of the same opinion, but he had been unable wholly to reduce forms to matter, and therefore was compelled to admit two kinds of substance, forms or ideas, and matter or body, although these again were modes of or was compelled to admit two kinds of substance, forms or ideas, and matter or body, although these again were modes of a still higher unity, the One. The deep thought of the learned Lucretius early fascinated Bruno, and Lucretius gave the trend not only to much of his philosophy, but also to the style of his writing. The Latin poems were suggested by Lucretius's De Rerum Natura, to which they are far inferior, certainly in literary charm. The philosophical system of the later writer, however, is not only bolder and grander in itself, but far more thoroughly worked out into the detail of exposition and of criticism. In the Italian dialogues also, Lucretius is constantly quoted, frequently from memory, as one may judge from the errors made. But in the first reaction against the now barren peripatetic philosophy, the school to which Bruno turned, with so many of his fellow countrymen, was that which nominally derived from Aristotle's immediate predecessor. The revival of Platonism in its secondary form of Neoplatonism was one of the most marked traits of the time. In connection with the attempt to unite the Greek and Latin churches in 1438, a Greek scholar came from Constantinople, one Georgius Gemistus Plethon, to the court at Florence, and there opened the minds of the Italians to the beauty of the Platonic philosophy. Its mystical world of ideas charmed all who were imbued with the new spirit, romantic, adventurous, hopeful, self-confident. The ideas, it is true, were materialized and personified in the transition through Neoplatonism, and it was as spirits of the stars and worlds, demons of the earth and sea, the living souls of plants and stones, that they appealed to minds fed on the grosser fare of medieval superstition. Platon's lectures, uncritical as they were, ensured the spread of Platonism in Italy. Bessarion of Trebizond, Marsilio Ficino, who became head of the Platonist Academy at Florence, and Pico of Mirandula followed in his steps. Both Ficino and Pico are mentioned by Bruno, and his knowledge of Plato, as of Plotinus, Porphyry, and other Neoplatonists, was derived almost certainly from Ficino's translations. The teaching of Plato was interpreted in the light of, and confused by admixture with, the mystical ideas of Philo and Plotinus, of Porphyry and Iamblichus, of the Jewish Kabbalah, and the mythical sayings of Egyptian, Chaldean, Indian, and Persian sages. The New World was struggling for light, and it rushed towards every gleam of brightness, however feeble. Thus, in the address to the Senate at Wittenberg before leaving the university, Bruno named the foremost of those whom he regarded as builders of the Temple of Wisdom. The list begins with the Chaldeans among the Egyptians and Assyrians. There follow Zoroaster and the Magi among the Persians, the Gymnosophists of India, Orpheus and Atlas among Thracians and Libyans, Thales and other wise men among the Greeks, and so down to Paracelsus in Bruno's own century. The fantastic grouping is characteristic of the uncritical syncretism of this last phase of Neoplatonism. Plethon had conjoined the dogmas of Plato with those of Zoroaster, and had confirmed both by illustrations from Greek mythology. Among the most widely read works were those of Iamblichus, the Platonist, who died early in the 4th century, the life of Pythagoras, and especially the mysteries of the Egyptians. Another work in many books which has not come down to us, but which penetrated into the literature of the Middle Ages, was on the perfect theology of the Chaldeans. To Iamblichus, as to Plotinus, the ideal world was a hierarchy of gods, from the ineffable, unsearchable one, down tier upon tier, through successive emanations, to the gods that are immanent in the world we know, and the things of the world. In the scheme, not only do the ideas of Plato, the numbers of Pythagoras, the forms of Aristotle, find a place, but also all the gods of the Greek mythology, of the Egyptian religion, of the Babylonian and Hebrew esoteric cults. The same character is to be found in the writings of the so-called Hermes, or Mercurius Trismegistus, to whom Bruno constantly appeals. It was partly for their cosmology, more in accord with modern thought than that of the Peripatetics and the Church, that they were read, but still more for the support their belief in demonic spirits, governing the movements of the worlds and of all individual things, gave to magical and theurgical practices, which, through the slackening of the rule of the Church, were now universal. All stars are called fires by the Chaldeans, writes Bruno. Animals of fire, ministers of fire, innumerable gods, divine oracles. The Chaldeans and the wise rabbis endowed the stars with intelligence and feeling. There are some who are by no means thought worthy of a hearing among philosophers. The Chaldeans and Hebrew sages who attribute body to the omnipotent God, calling him a consuming fire. Below him were innumerable gods, flames of fire and spirits of air, which were subtle, active, mobile bodies. Souls, too, were spirits, that is, subtle bodies, and Bruno adds, "We do not pursue this mode of philosophizing, but are far from despising it, nor have ever thought that a wise man should think it contemptible." The theology or theosophy of the Egyptians is praised in the Spatio, the magical and divine cult of the Egyptians, who saw divinity in all things and in all actions, each manifesting divinity in its own special way, and knew by means of its forms in the bosom of nature how to secure the benefits they derived from it, as out of the sea and rivers it gives fish, out of the deserts wild beasts, and out of mines metals, out of trees fruits, and out of certain parts of nature. Certain animals, certain brutes, certain plants are gifted certain fates, virtues, fortunes, or impressions. Divinity in the sea was called Neptune, in the sun Apollo, in the earth Ceres, in the deserts Diana, and diversely in each of the other species of things. As divine ideas, they were diverse deities in nature, and all were referred to one deity of deities, one source of ideas above nature. The passage shows clearly the connection between the revived enthusiasm for the old pagan cults and the new but dark beginnings of independent study of nature, in magic, divination, alchemy, and astrology. Equally close was the connection of both with the revival of pantheism, the conception of nature as a single whole, throbbing with one life, springing from one single source. So of the Hebrew Kabbalah, Bruno writes, "Its wisdom, whatever it be in its kind, derives from the Egyptians, among whom Moses was brought up. In the first place, it attributes to the first principle a name ineffable, from which proceed in the second place 4 names, afterwards resolved into 12, these into 72, these into 144, etc., etc. By each name they name a god, an angel, an intelligence, a power that presides over a species of things, so the whole of divinity is reduced back to one source, as all light is brought back to the first self-shining light. And the images in the diverse innumerable mirrors, particular existences, are referred to one formal ideal source. As might be expected, Plato himself was best known to the school through one of the least characteristic of his works, the Timaeus, with its fantastic cosmology and demonology, alongside of which was placed the work of the Pseudo-Timaeus of Locris, a later writing based upon that of Plato, although professing to belong to an earlier date. Next to these in importance came the Republic, with the theory of ideas. It was from the Chaldeans, Egyptians and Pythagoreans that Plato was supposed to have derived his cosmology. It is, however, with the system of Plotinus that Bruno's earlier theory has the closest affinity. He passed far beyond that system, as the following chapters may show, but many of the ideas that had come down from the master remained throughout part of the basis of Bruno's thought. Such are, for example, the idea of the universal intelligence, distinct from the one, the highest and unknowable being, or God, as the soul of the world and the source of the forms of material things. The rationes, or ideas which are contained in it, mould and form all things from the seed onwards. The seed is a miniature world containing implicitly, which is in its ratio, form or soul, the perfect thing. The conception again of the lower sensible world as an imitation of the higher, the intelligible, is derived from Plotinus, as is that of the 7 grades or steps of emanation from the first principle to the material world, which correspond to the 7 grades by which the human mind rises from the knowledge of sensible things to that of the highest, the good. The order of knowledge corresponds step for step with the order of emanation, of creation. Most significant of all for the development of Bruno's philosophy was Plotinus's conception of an intelligible matter, which is common to all the different beings and species in the intelligible world, just as brute matter is that which is common to all kinds of corporeal objects. Again, from Plotinus derives the distinction that the matter underlying the intelligible world is all things and altogether. Having in it implicitly all forms, there is nothing into which it may change. Whereas the matter of the sensible world becomes all by change in its parts, becomes at successive moments this and that, is therefore at all times in diversity, change, movement. Matter of either kind is never without form, but all forms are in them in different ways, in the one in the instant of eternity, in the other in the instance of time, in the one all at once, in the other successively, in the one complicitly, in the other explicitly. The same idea is attributed in the De Immenso, Book 5, to the Platonists, that God has imbued celestial matter with all forms at once, but gives them to elemental matter in single moments, just as he has poured into the nature of the gods all ideas once for all, but instills them into animal nature day by day. And as in the order of minds, there is an ultimate principle which is incorruptible, so in the order of bodies. For the order of bodies follows that of intelligences as a footmark follows the foot, as a shadow follows the body. Hence, whatever order is proved to hold of minds, the same will be found to hold of bodies. It only remained to identify the 2 kinds of matter, the divine and the elemental, the spiritual and the corporeal, to obtain the pure pantheistic naturalism of the middle period of Bruno's philosophy. At that stage, he was no longer in sympathy with the Neoplatonist psychology and denied the doctrine of a separate intelligence or understanding in man, an intelligence, that is, of different origin from sense and therefore of different kind. He rejected also their view that the imagination, which is the source of instinct in animals, differs from human imagination, and their assertion of a difference in kind between reason and intellect in man. For Bruno, as the order of nature was throughout the same in kind, constituted of similar elements, so the order of thought or knowledge was one in kind, from its lowest phase in sense to its highest in the divine ecstasy. In the Heroici Furori, as again in the posthumous De Vinculis in Genere, the Platonic doctrine of the ascent to the ecstatic vision and love of divine beauty, from sense perception and the material feeling for sensible beauty, is the essential topic throughout. And in both, Bruno is largely indebted for his symbolism to the Neoplatonist mystics. The renewed passion for physical science brought another school of philosophy into prominence, the Arabian. The chief commentaries of this school on Aristotle, as well as many of their original writings, were translated and published before the middle of the 16th century. Their interest being directed rather towards the physical and metaphysical writings of the master than towards the logical, they helped to satisfy and to foster the growing spirit of inquiry, and at the same time to spread abroad a more exact knowledge of the real Aristotle than was to be derived from the Christian commentators, whose philosophy was much less in sympathy with Aristotle's than was imagined. The general trend of the Arabian school in metaphysics was towards a modified Aristotelianism, leavened by the Neoplatonist conception of the essential unity of all being and all thought, particular things and particular ideas being a free outflow from the one, into which they of necessity return again without affecting its fundamental nature. Bruno was familiar with Avicenna, Avempas, Avisbron, Algazel, and above all Averroes. Avisbron or Avensbron was the author of the famous Fons Vitae, the source of life, which gained a quite undeserved notoriety for its supposed materialism. Bruno did not know it at first hand, but through quotations in the translated Arabian writings and criticisms in the scholastics. Accordingly, his idea of it is by no means accurate. He knew that Avisbron had spoken of matter as divine, that he had reduced even the substantial forms of Aristotle to transitory phases of matter, the stable, the eternal, progenitrix, mother of all things, and had shown the logical necessity of assuming a matter or ground, out of which corporeal nature on the one hand, incorporeal or spiritual on the other. This doesn't mean ignoring it. It is clear that this underlying matter was not material in the ordinary sense, but a unity which in itself was neither corporeal nor spiritual, yet in its different aspects was both at once. That is a conception which formed one of the main theses in Bruno's philosophy. Directly or indirectly, he drew from the Fons Vitae the thought of a common something which runs through all differences, which is their basis, and gives them reality, which stands to them in the relation of Aristotle's matter to forms. Under the differences of bodily objects there lies one common matter, under the differences of spiritual beings another, and under the differences of these two secondary matters lies a primary matter in which both are one. So too, the progress of thought is from the most complex, or composite, material bodies, through the less complex, the spiritual, to the highest and simplest, the one. Of Algazel's Makachit, a resume of the chief philosophical systems, which were criticized in a second part of the work, a translation was published in 1506. Although an orthodox theologian, he taught Bruno that the sacred books had as their end not so much truth or knowledge about reality, as goodness of custom, the advantage of the civil body, harmonious living together of peoples, and practice for the benefit of human intercourse, maintenance of peace, increase of republics. In other words, that the Bible claimed no authority in regard to matters of historical fact or of natural science, but contained a revelation of moral or practical, rather than of speculative or theoretical truth. For Averroes, Bruno has the highest respect. He constantly speaks of him as the most subtle and weighty of the peripatetics. Averroes, though an Arab and ignorant of Greek, is more at home in the peripatetic doctrine than any Greek I have read, and he would have understood it better had he not been so devoted to his deity Aristotle. This blind faith in Aristotle was the weak spot in Averroes' armor and the cause of many of his subtleties. He could not believe that Aristotle, whose knowledge was coextensive with creation, could have erred. Rather than deny Aristotle, he refused to believe his own senses. In philosophical theory, there were at least 2 points of contact between Bruno and the great Arabian. One was the doctrine that forms, more precisely, individual particular objects are sent out from, and therefore originally contained in matter, or in modern phrase, that the evolution of natural objects is from within outwards, not imposed upon nature by an alien and separate creator. The other was the theory of a universal intelligence pervading and illuminating all human minds, yet remaining one and the same in all, itself an emanation from the divine, and the lowest in the order of intelligences. Bruno did not, however, speak of it as separate from the finite minds, but as immanent in them. Nor did he regard it as the only immortal element in man. Of the scholastics proper, from whom much at least of Bruno's terminology is derived, 2 seem to have influenced him most strongly. Albert the Great, whose interest in natural science entitled him to a place in the Temple of Wisdom. He had no equal in his time, and was far superior to Aristotle, whose school, in which he ranked according to the conditions of his age, was unworthy of him. And Thomas Aquinas, the angelic doctor, honour and glory of all and every race of theologians and of peripatetic philosophers. Generally speaking, however, the scholastic is to Bruno the pedant, the dabbler in words, as contrasted with the student of nature or of reality. Under this condemnation fell 2 of the greatest innovators upon the Aristotelian philosophy of his own time, Remus and Patrizzi. The great logician was merely a French arch-pedant who has written The School upon the Liberal Arts and the animadversions against Aristotle. We may admit that he understood Aristotle, but he understood him badly. And had he understood him well, he would perhaps have been minded to make honourable war upon him, as the judicious Telesio has done. The fashionable philosopher and Platonist is un altro sterco di pedanti, an Italian who has soiled so many choirs with his Discussiones Peripateticae. We cannot say he understood Aristotle, either well or ill, but he has read and reread, stitched and unstitched, and compared with 1,000 other Greek authors, friendly and unfriendly to Aristotle, and in the end has undergone great labour, not only without any profit, but also with very great disprofit, so that he who would see into what presumptuous folly and vanity the pedantic habit may plunge a man, let him look at that book, before the memory of it is lost. Tocco has laid his finger upon the reason for Bruno's dislike of these moderns, and it explains his objection to the scholastics generally. It was that they attempted to remodel and reform the logic and rhetoric of Aristotle, the very parts of his work which Bruno regarded as the most perfect, and neglected the physical works, the theory of which had so powerful an authority to back it, and therefore all the more required the energies of the stronger minds of the time to be directed upon it. One of the medieval writers Bruno associated so closely with himself that his indebtedness might easily be exaggerated. This was Raymond Lully, whose grim figure stands out from the shadowy 13th century, the author of the celebrated art of reasoning. The object of the art was to tabulate the primary forms or elements of thought, and their modes of combination, from which data it was believed any process of reasoning, however complex, might be carried out, without greater expenditure of energy than in performing an arithmetical operation with any of the first 9 numbers. There was no question of a possible divorce between thought and reality. The result of any such process of rational calculus properly carried out was truth. Bruno thought with Lully that the ultimate ideas within reach of human thought were at the same time substantial elements in reality, and that the completest knowledge of reality, short of the absolute, was within the power of human reason to achieve. Lully included in this rational sphere the dogmas of Christian theology. Faith was for the many, who must be driven to believe. Reason for the few, the wise. Lully's method attracted, and his teaching influenced nearly all the greater minds of the later Middle Ages and of the Renaissance. They became a source of as bitter contention as the doctrines of Aristotle himself. Bruno speaks of Lully as almost divine. Agrippa, after being an ardent follower, came to see the vanity of the system, and Bacon called it a method of imposture. At different times, Bruno expounded, criticized and expanded the art. He claims to have embellished the method of him whom the best leaders among philosophers admire, follow, imitate. Duns Scotus, Scotigena, Nicholas of Cusa, Paracelsus, Agrippa are named unjustly as having drawn their chief doctrines from this source. Lefebvre and Bouille cited among his most recent followers. The art was taught by some divine genius to a rude, uncultured hermit, and although it seems to issue from one too dense and stupid, yet it excels the teaching of any famous Attic orator in this kind, as a crop of wheat excels one of barley. It seemed to us unfitting that this work, struggling upwards to the light, against the envy of oppressing darkness, should be suffered to perish and be lost. Yet Bruno by no means thought Lully's exposition perfect. Of his own Lullian work, the De Compendiosa Architectura, he says that it suffices for the understanding, estimating, and prosecuting of the art of Lully, by those who are skilled in the vulgar philosophy. For in it is expressed in one whole all that is in Lully's many arts, in which he always seems to be saying the same thing. You have there all that is in the Ars Brevi, the Ars Magna, and other books bearing the name of Arbor Scientiae, Inventionis, Artes Demonstrativae, Mixionis Principiorum, Auditus Cabalistici, or any other of that kind, in which the poor fellow strove always to express the same thing. It was the dream of universal knowledge that attracted Bruno and others to Lullism, just as the dream of universal power over nature attracted the greater minds of the Renaissance to the pseudo-science of alchemy. The same idea is at the root of both. All things are in all things, which is the one fundamental nature is in each and every individual thing, therefore out of any one may be produced any other. So in the idea of any one thing, the knowledge of all and any others is necessarily contained, requiring only a proper method for its extraction, as out of the seed may be brought the great tree. Therefore to Bruno, the hermit Lully seemed omniscient and almost divine, his method an inspiration from above. There is little, however, to connect Bruno with the substantive teaching of Lully, apart from the method. He explicitly rejects, for example, the main contention of Lully, that the Christian dogmas are capable of demonstration by reason. Those relations, more specifically between God and man, which have been revealed to the worshippers of Christ alone, are contrary to all reasoning, philosophy, other faiths and superstitions, and allow of no demonstration but of faith only, in spite of what Lully in his madness, delirando, attempted to do, in face of the opinion of the great theologians. Foremost of all, however, of the influences which directed Bruno's thought was that of the Cardinal Nicolaus of Cusa, Nicholas Cripps. A pre-Reformation reformer, he stands both in theology and philosophy between the old and the new eras, summing up in his own theory the purest theology and the most refined philosophy of the Middle Ages, yet inevitably pointing forwards to a scientific and religious reform which should transcend both. Where, cried Bruno in his oration at Wittenberg, will you find his equal? And the greater he is, the fewer are they to whom he is accessible. Had not the robe of the priest infected his genius, it would have been not merely equal to, but far superior to that of Pythagoras. He knew and discerned much, and is truly one of the most gifted natures that have ever breathed the air of heaven. But as to the apprehension of truth, he was like a swimmer in tempestuous waters, cast now high, now low. He did not see the light continuously, openly, clearly, did not swim as in calm and quiet waters, but interruptedly at intervals, for he had not cast off all the false principles which he had received from the common doctrine. His starting point. A sketch of the philosophy of the Cusan will show in how close a relation Bruno stands to him, yet how great is the difference in outcome between the two philosophies. Clemens, whose sympathies are with the orthodox theologian, does not hesitate to say that this is the real and direct source from which Bruno drew with both hands, the philosophy to which he owes many of the main principles of his nature philosophy, and which he has to thank for all the essentials of teaching, said to be peculiar to himself. And Falkenberg is equally inclined to underrate the originality of the Italian in preference to the German philosopher. The outset of Cusanus's philosophy is from a theory of knowledge which he held from Platonist traditions. Knowledge is posterior both in time and in value to being, or reality, of which it is at best a copy or a sign. Hence reality can never be wholly comprehended by it. Every human assertion is at best a conjecture, a hypothesis or approach to truth, but never the absolute truth itself. Only in the divine spirit are thought and reality one. The divine thought is at the same time creative, human only reflective, imitative. Thus the ultimate being is and must remain incomprehensible for human minds. So Bruno also taught. The Cusan did not, however, reject on this account all human knowledge. On the contrary, reason approximates ever more and more closely to the divine mind, as a polygon approaches more and more to the form of a circle when the number of its sides is increased. As it never becomes an actual circle, so the divine reason may be known ever more and more truly through human reason, but never quite truly. It is the knowledge of this, our essential ignorance of the divine, that brings us nearest to it. Thus, although from one point of view, all that is best in human experience may be attributed to the divine nature in a higher form, positive theology, from another every predicate, even the highest, may be denied of it, negative theology. Or from still a third standpoint, mystical theology, contrary predicates equally hold or do not hold of the divine. This coincidence of contraries, suggested perhaps by the tradition of Heraclitus and Empedocles, was in the Cusan a principle of knowledge merely. The divine was at once the greatest and the least. Greatest because we could not imagine it added to, for it was the all. Least because, being truly existent, we could not imagine anything taken away from it. It is owing to the limits of human thought, therefore, that God is at once greatest and least, equal and unequal, many and one. God himself is free from all contradiction. The apparent contraries of our understanding are in him one and the same. So to our imagination, the infinite circle coincides with the infinite straight line, and a top spinning with its fastest movement appears to stand still. Bruno extols the greatness of this discovery. Considering it physically, mathematically, morally, one sees that the philosopher who saw into the coincidence of contraries made a discovery of the highest importance, and that the magician who knows to seek it where it is no feeble practician. Yet although he made use of the same geometrical illustrations, and believed himself to be where it is, whose circle coincides with the infinite straight line, and a top spinning with its fastest movement appears to stand still. Bruno extols the greatness of this discovery. Considering it physically, mathematically, morally, one sees that the philosopher who saw into the coincidence of contraries made a discovery of the highest importance, and that the magician who knows to seek it where it is no feeble practician. Yet although he made use of the same geometrical illustrations, and believed himself to be substantially following Cusanus, his theory was widely different. The coincidence springs in Bruno not from the limitations of the human mind, but from the fullness of the divine nature. It is not in God as the transcendent unknowable being that the coincidence inheres, but in the infinite universe as one with God, which is in itself at once the greatest and the least, the maximum and the minimum. Since nature is permeated by God in everything, in the least of things is God the greatest, the least is the greatest, has in it the nature of the whole. And so too, the greatest is the least. In Bruno, it is a pantheistic, in the Kuzan, a theistic doctrine. The same conception occurs again in its different meanings, when both compare God to an infinite circle, in which center and circumference are one. In Cusanus, it is to our knowledge that he so appears. In Bruno, he really is infinite, and is with his whole nature at any point or center, as well as in the whole, the circumference. With the Kuzan, the threefold nature of the highest being is deduced as a necessity of reason. It is 1, unity eternal, 2, sameness or equality eternal, and 3, the union of unity and equality. As there cannot be 3 eternal and highest beings, these 3 are necessarily one. The unity, the Father, produces or begets from itself the same, the Son, and out of both springs their union, the Holy Ghost. Yet each of these in the one is one and the same. In the universe, the created world, there is also a Trinity, since it is a copy or reflection of the divine. 1. Possibility or matter, the unlimited, indeterminate, but capable of being limited and determined, corresponds to the unity of the eternal. 2. Actuality or form, the limiting or determining something, that which limits corresponds to the sameness or equality of the eternal. And 3. The unifying movement by which the possible receives actuality. Matter receives form, implying a spirit of union of love, corresponds to the absolute union, the Holy Ghost. At a later stage of his philosophy, however, the Kuzan gave a second deduction of the Trinity. God is both absolute possibility, absolute power or potency, the creative word, the Son, and the union of both in absolute reality. Yet these are merely different aspects or points of view of the eternal being. Again, God is the identity of knowing, or intellect, the knowable or intelligible, the word, and love as the interrelation of each with each, the striving of the knowing after the knowable, its highest good. Bruno also adopts the trinity of possibility or matter, potency or form, and reality, but it is applied at once to God and to nature as two sides of the same thing. As the divine potency is infinite, so is nature, its expression infinite. Matter and form do not in their origin stand opposed to one another, as if separated from one another, any more than power and possibility are separate in God. All that can be is realized. Matter has in itself all possible forms, and produces these out of itself in the successive moments of time. The universe is eternal, therefore, in order that the infinite power may in it be realized. In all these respects, Bruno transforms the orthodox Cusanus' conception of a created and finite world, although nowhere perhaps has the idea of a creation been more skillfully woven into a profound philosophical system than in the Cardinal's quaint dialogues. The Cusan does not attempt the impossible to account for the fact of creation. God comprehends or contains all things, for all things are in him, and he unfolds all things out of himself, for in all things he lives. But the essence and the process of the comprehension and the unfolding are unknowable by us, just as we can never understand how chance comes to be united with necessity, creation, in the world. It is to this incomprehensible partnership that the imperfections of created things are attributed. In its reality, the universe is finite, limited. In its possibility, which is its idea, it is infinite, but only privatively infinite. That is, God could still call a more perfect universe into existence than it has actually pleased him to do. Only he, as the absolute greatest, is infinite in the full negative sense. More precisely that which can neither be nor be thought greater than it is. Here Bruno's theory is in complete contrast with that of the Cusan. There are, however, many consequences that both alike have drawn, as that no two things in the universe are wholly and in all respects alike. The identity of indiscernibles. Each thing expresses the nature of the whole in a special way, but all things may be arranged in graduated scales from the lowest to the highest, or from any one to any other. More precisely, there are no absolute differences, only differences of degree. Nor are there absolute centers in the universe or in any of the worlds, nor perfect figures. Thus, there are no perfect circles described, for example, by the planets in nature. A further corollary was that the whole is mirrored in each of the parts, as each particular thing partakes of the soul or creative force of all. Each does not, however, mirror or reflect the divine nature with the same adequacy as every other. Some do so more perfectly than others, man most perfectly of all. Cusanus did not definitely accept the suggestion of a soul of the universe, analogous in its relation to the world to the soul of man in the body. Still less did he identify it with God, as Bruno tended more and more to do. Hence he escaped the fantastical consequences of the belief in universal animism, which were drawn without reserve by the Renaissance writers. The consequence, for instance, that if one soul, one nature pervades all things and is the life of all, things then out of each may be produced any other, out of lead, gold, etc. On the other hand, the four elements at least were different forms of the same fundamental being, and might be produced each out of the other. And in common with Bruno, Cusanus held the pre-Aristotelian belief in atomism. There cannot be division of anything, cube or surface or line, ad infinitum. Ultimately, there must in each kind be a minimum, an atom beyond which we cannot in fact go, although to thought it may be still further divisible. So there is in every figure, in every kind of thing, a definite number of atoms. It was partly this thought, partly also the mystical value from time immemorial, given to the different numbers and geometrical figures, that led both Cusanus and Bruno to look to mathematics and geometry for the true method or organon of natural science. Number is the natural and fruitful principle of the understanding's activity. Irrational beings do not number, but number is nothing but the unfolding of the understanding. Without it, the understanding would have none of the results to which it attains. Nothing can exist before number, for all that goes beyond the simplest unity is in its fashion a composite, and therefore without number is unthinkable. For multitude, difference and relation of parts arise from number. In both again, human knowledge proceeds inversely as creation or emanation from number, the many, back through successive grades of simplicity to the one highest, most simple, God, in whom are all things complicitly, without number. What appears to us as after another successive is by no means after in thy thought, which is eternity itself. The single thought, which is thy word, embraces, complicate, all and each in itself. Thy single word cannot be manifold, opposite, changeable. In the eternity in which thou thinkest, coincides all the after another of time with the now of eternity. There is therefore no past nor future where future and past coincide with the present. The merely logical understanding, that which is based upon sense and requires sense images for its material, is inadequate to this highest knowledge, gives approximation merely, and we are thrown back upon mystical intuition, on the one hand, reasoned faith on the other, for our insight into the true nature of the one and the all. Other influences which gave direction to Bruno's genius belong rather to physical science and pseudoscience than to philosophical theory. Cornelius Agrippa of Nettesheim, 1487-1535, the scholarly adventurer, the Faust, who acquired all the knowledge and most of the arts of his time, wrote a compendium and justification from Neoplatonist philosophy of magical practices, and at the close of his life the great declamation on the uncertainty and vanity of all sciences and arts, a plea for the simple life and the simple gospel. The De Occulta Philosophia is the chief source from which Bruno drew the fantastical lore of the Demonade, the satires upon asinity, as the chief human virtue in the Spatio and the Kabbalah, directed as they are against blind faith without works or wisdom, found their occasion at least in Agrippa's praise of the ass, in the Divinitate, as the mouthpiece of God in the story of Balaam, and the bearer of Christ in the New Testament history. Paracelsus proposed a reform of medicine on Neoplatonist principles, attacking the Galenian doctrine of the four humours, which was based on the four elements of the Aristotelians, the warm and the cold, the moist and the dry. His own more natural theory made salt, sulphur and mercury the chemical elements of all things, those which in living organisms were vivified and directed by an inner spirit, for example the archeus in man, a direct emanation from the soul of the universe. Through their common constitution and the spirit that infused all things alike, there was a subtle, mysterious sympathy between the microcosm and the macrocosm, the individual body and the universe, and it was by the study of the relations, magical, astrological and the rest, between the stars and the things of earth, between the different metals and the body of man, that Paracelsus proposed to reform the art of medicine. Bruno, in the Causa, praises Paracelsus for his philosophical treatment of medicine, that he did not rest content with the three chemical principles alone for explanation of the different vital phenomena, but sought the true principle of life everywhere, in a spirit or soul. He is one of the builders of the Temple of Wisdom, ad miraculum medicus. In his magical writings and in the De Monade, Bruno is largely indebted for materials to Paracelsus. The same general tendency, the desire for a return to nature and to sense observation as opposed to the authority of Aristotle, and to the cult of logical or grammatical subtleties, is found also in Cardan. In his work, there is the same mixture of mathematics and physical science with theology, magic and Neoplatonism. And to him Bruno owes many of his superstitions. The more profound Telesio, also, who before Bruno made honourable war upon Aristotle, attempted, independently of all authority, from sense knowledge and induction alone, that gave the decisive trend to Bruno's thought, holding him fast to the one all-important fact that the earth is not the centre of the universe, but one of its humblest members. Without the solid arguments of Copernicus, Bruno's superb conception of the cosmic system would have remained a dream, an intuition of genius, rather than a well-grounded forecast of modern scientific discovery. There is more understanding, said Bruno, in 2 of his chapters than in the whole philosophy of nature of Aristotle and all the Peripatetics. Grave, thoughtful, careful, and mature in mind, not inferior to any of the astronomers that went before him, in natural judgment far superior to Ptolemy, Hipparch, Eudoxus, and all the others that have walked in their footsteps, a height he attained by freeing himself from the prejudices, not to say blindness, of the vulgar philosophy. Yet he did not get beyond it. Being more a student of mathematics than of nature, he was unable wholly to uproot all unfitting vain principles, to solve all contrary difficulties, liberate both himself and others from so many vain inquiries, and fix their contemplation on things abiding and sure. With all that, who can sufficiently appraise the greatness of this German, who paid little heed to the foolish multitude, and stood solid against the torrent of opposing belief? Although almost destitute of living reasons for weapons, he took up those cast-off and rusty fragments that he could get to his hand from antiquity, repolished them, brought the pieces together, mended them, so that through his arguments, mathematical rather than physical though they were, he made a cause that had been ridiculed, despised, neglected, to be honoured and prized, to seem more probable than its contrary, and certainly more suitable and expeditious for calculation. Copernicus had put forward the theory as a hypothesis merely, and had shown how much more simply the different positions of the sun and planets as seen from the earth could be explained by it, and how much more accurately they could be calculated. In the epistle prefixed to his work, said by Bruno not to be by Copernicus himself, the reader was warned of the folly of taking this hypothesis as true. To Bruno, the contrary of the hypothesis was absurd. Bruno did not appreciate the mathematical proofs of Copernicus, and constantly spoke of him as too much of a mathematician, too little of a physicist. His own mathematical demonstrations were, however, much less successful than those of his predecessor.
Sponsored by SimpliSafe. There's no safe like SimpliSafe. Hey, fellow seekers, I'm Mr. Mythos. On a humid summer night in 1677, a trembling painter named Johann Christoph Heismann staggered into a small Bavarian monastery in Pottenbrunn, Austria. At first, the monks who opened the heavy wooden doors suspected he was a criminal seeking sanctuary from the law, but the truth was that Heismann was fleeing from something infinitely darker. His words were disjointed and feverish as he began to recount horrifying visions and being relentlessly stalked by a demonic entity who manifested either as a finely dressed noble or as a grotesque horned monster. Upon questioning from the monks, Heismann admitted that almost a decade prior, he found himself in financial ruin and emotional collapse after his father's sudden death. At his most desperate, he performed an occult ritual to summon a demon, which manifested in his home and promised relief from his suffering, if only the artist would sign his name. It was a 9-year contract and it was nearly due. The demon had come to collect his soul. Clutching a bundle of parchment, Heismann revealed that he'd kept a diary of his experiences. The monastery's record keepers were trained to distinguish madness from genuine spiritual affliction, and over several days, they examined his diary and realized this went far beyond any usual claim of seeing devils. Recognizing textbook patterns of demonic activity, they knew this young man had to be exorcised as soon as possible. However, for reasons we'll learn, the diabolic onslaught intensified to an extreme degree before Christoph Heismann was ultimately set free. Authenticated records of these events, including copies of the Infernal Pact, Heismann's diaries and paintings of his demonic tormentor, and the reports made by his exorcists, were preserved in the archives of the Basilica of Mariazell in Austria. It's one of the most vivid and meticulously documented cases of a demonic pact, and it's been studied not only by Catholic exorcists for centuries, but also famously by Dr. Sigmund Freud, the father of psychoanalysis. With black ink and his own blood, Christoph Heismann signed a satanic contract. Yet that's hardly the full picture, as by the end of his horrific experience, he'd been hit by nearly the entire spectrum of what Catholic demonology defines as extraordinary demonic activity. Historically, the Catholic Church distinguishes ordinary from extraordinary when it comes to what demons do. Ordinary are those day-to-day temptations to lie, cheat, indulge, or otherwise turn away from virtue and God. These fleeting urges can be resisted, but never fully eradicated from our lives, and every person is subject to ordinary demonic temptation in this sense. However, church exorcists, and notably the late Father Gabriele Amorth, known as the Pope's exorcist, distinguish a class of far rarer and much more supernatural and severe assaults as extraordinary. This distinction separates everyday spiritual struggle from the horrors that drove Christoph Heismann to the monastery for help. Catholic tradition and official exorcism manuals explicitly recognize 6 categories of extraordinary demonic activity in order of increasing severity. First, temptation in its intensified extraordinary form. Second, obsession, or persistent disturbing thoughts and emotions. Third, infestation, a demonic presence tied to a physical location, similar to a haunting but operated by the forces of hell. Fourth, oppression, or external attacks on a victim physically or their life circumstances. Fifth, possession, the unconsented invasion and control of the victim's body. And sixth, subjection, this being a willing pact with demonic entities, otherwise understood as voluntary enslavement. We'll be diving deep into all 6 of these categories in order, learning what they are and how to defend and fight against them, exploring their roots in biblical scripture, apocrypha, and occult texts, and investigating several of history's strangest documented cases of demonic activity. Finally, over the course of our journey, we'll see the complete progression of how Christoph Heismann went from an orphaned artist tempted by occult promises to a demon's contract-bound son, forced to retrieve his own blood-signed pact from hell. This is the first volume of our 2-part descent into the manifestations of extraordinary demonic activity, a topic so broad that one video wouldn't cut it. Today, we'll cover the first 3 on the ladder: temptation, obsession, and infestation. By the end of this first volume, you'll understand how demons parasitically attach themselves to human lives and environments, and rip open the gates for the final 3 categories that we'll explore in the second volume. As with my previous videos on demonology, we'll approach this topic from the lens of Christian belief and Western occultism. While most of the world's major religions believe in demons, if you're a skeptic or an atheist, you might interpret these phenomena very differently. We live in an age where mental illness, mass hysteria, or neurological disorders might explain many cases of supposed demonic activity, and rightfully so. Catholic exorcists maintain that the majority of self-reported demonic encounters are not legitimate. That said, they stand firm that certain cases are. Whether we believe personally, the Church has taken the study of demonology seriously since the 2nd century AD, and to them, demons are real. It's a borderland between theology and terror, and all very interesting. So we're going to get obsessively detailed with it. Not obsessive as in the second category of demonic activity, but obsessive as in I've spent several months researching and writing these 2 volumes. So just remember, have no fear, Mr. Mythos is here. This is extraordinary demonic activity, explained in obsessive detail. Before we dive in, protection from malevolent entities has been important for millennia. Rituals, incense, and sigils shielded against evil. While we'll explore spiritual defenses in today's investigation, my home also requires vigilant protection against tangible threats. Today's sponsor of SimpliSafe is my personal home security system. I've had equipment stolen in the past, but far more importantly, I share my home with my wife, parents, and our 3 cats and 2 dogs. I'd never risk their safety. SimpliSafe provides us total security with smart locks, HD cameras, and advanced sensors that detect break-ins, fires, floods, and more. I installed it all myself, and their app makes it easy to arm my fortress, view camera feeds, and manage alerts from anywhere. And 24/7 professional monitoring means that their agents call me in emergencies and can dispatch first responders, even if I can't pick up or I'm not home. SimpliSafe also released a new service called ActiveGuard Outdoor Protection that doesn't wait for trouble to break in, but stops it outside, day or night. Their advanced AI can tell friend from foe and contacts a trained agent to handle it in real time, questioning any suspicious lurkers, triggering alarms and spotlights, and requesting urgent police dispatch before any would-be criminal steps foot inside. With a 60-day satisfaction guarantee, no long-term contracts or cancellation fees, and award-winning plans starting under $1 a day, SimpliSafe offers true peace of mind. And when I know my family and home are safe, my focus can stay where it belongs, on diving into these mysteries. Save 50% off your SimpliSafe security system when you sign up for a professional monitoring plan and get your first month free. Visit simplysafe.com/mythos to customize yours. If you don't love it, return it for a full refund within 60 days. There's no safe like SimpliSafe. Thanks again to SimpliSafe. With my sanctuary secured, let's set off to the underworld of extraordinary demonic activity. Imagine a whisper so subtle it feels like your own thought. A suggestion with the gentle persistence of water on stone. This is how the oldest war begins, not with violent demands, but a quiet invitation. Of these 6 forms of demonic activity, temptation might appear the most benign. After all, everyone experiences it. But what separates ordinary temptation from its extraordinary counterpart is the sheer intensity, manipulative long-term strategy, and high stakes. With ordinary temptation, you might stretch the truth on your resume or sneak a forbidden snack into the movie theater. But it's a much more alarming problem if you find yourself plotting serious crimes, betrayals of trust, or even trading your soul. The demonic mechanism is crucial here. The entity can suggest, entice, and deceive you, but it can never force you to do anything. Your free will remains intact. Paradoxically, however, extraordinary temptation often requires more than willpower alone to combat. In stressful circumstances, our emotions can possess us much like a demon. In a literal sense, you still yield to the temptation yourself. But one could argue that our emotions limit how much free will we actually have. When you lose control to yourself, are you really in control? But we're not here to dive into philosophy. We're focusing on how the demons are involved. In the infernal economy, temptation is reliably profitable because demons are said to have the supernatural ability to identify and target our deepest vulnerabilities with extreme precision and timing. For Christoph Heisman, it began as bad decisions often do, in the heat of the moment, in a really bad situation. Christoph Heisman was born around 1651 in Traunstein, Bavaria. Little is known of his youth. As a painter, he showed talent but never achieved notable success. Then, in his mid-teens, his father died, leaving Heisman as an orphan. According to his diary, this triggered a nervous breakdown and plunged him into such a profound depression that he could barely function, let alone support himself through his art. He was poverty-stricken, anxious about his future, and utterly alone. In the rather fitting year of 1666, the teenage Heisman obtained a black magic goetic grimoire and performed a ritual invocation to summon a demon in hopes of escaping his misery. The entity appeared before him in the form of a wealthy elderly nobleman with a brown beard and fair complexion, elegantly dressed in a red cloak, black hat, and a black walking stick. A huge black dog sat panting beside him. During this first encounter, the demon offered him wealth and fame in exchange for servitude. Interestingly, Heisman rejected the proposal. Over the next 2 years, the fiend appeared to him 9 separate times, abandoning its gentlemanly disguise for more grotesque and terrifying forms that the artist would later capture in a series of paintings. In one illustration's caption, Heisman described the 3rd time, where the demon manifested, quote, in this loathsome shape, with a book in his hand which was full of magic and black arts, end quote. The entity gifted him this book of forbidden knowledge, but Heisman ultimately burned it, provoking the demon's fury. Quote, the fiend reproached me violently for having burnt his aforementioned book and threatened